This is R.D. Sharma Solution, Class 12th, Chapter 11, Differentiation exercise is 11.2. So in this exercise, we will be using the direct results. So here are certain direct standard results of differentiation, and we have already done most of them using the first principle. So this exercise has more than 70 plus questions, and those where only these final result will be used, we'll employ that. So we have differentiate sine 3x plus 5. Now remember, this sine, if I assume it to be sine theta, so first we have to do the differentiation of sine theta or sine whatever the content is. Then we have to differentiate the 3x plus 5, that is theta. Then whatever is inside, means we will go up to the limit where the differentiation can happen. That is called the chain rule. Because we know that sine theta, the differentiation is simple cos theta. But here we are dealing with sine 3x plus 5. So what we have to do here is d by dx of sine theta means first you have to do it the normal way, cos theta. Whatever is theta, 3x plus 5 you can write. Now you will not stop here. Using the chain rule, you will also differentiate 3x plus 5. That is d by dx of 3x plus 5 has to be done. D by dx of x is 1. You don't differentiate the constant value, it always comes outside. And a simple constant value is going to give you 0. That is, this cos 3x plus 5 will come in front. And then d by dx of 3x plus 5, how to do this? D by dx of 3x plus d by dx of 5. So this constant, it always comes out. So you can call it as 5 into d by dx of 1, that is going to be 0. And 3 into d by dx of x, that is going to be 1. D by dx of x is 1. This is for x. If it is, can be assumed to be power of 1. So 1, this is nx to the power n minus 1. 1 comes in front and then x to the power 1 minus 1. That is x to the power 0. And anything to the power 0 is always 1. So the result of x d by dx is 1. So only 3 will come. The d by dx of 1 is, of course, it is a constant. So it is going to be a 0 value. So cos 3x plus 5, whatever is coming, that is 3 is coming, that you can write in front. Differentiate tan square x. Now same thing we are going to apply here. Same way we have to do this. This is tan x. Assume it to be, say, some y. So basically you are differentiating first y square. So d by d, whichever, I am writing y, so I am just writing y in the denominator. It is not like that, just to make you understand I am doing this. So d by y of y square is 2 into d by d y of y. That is nx to the power n minus 1. So this is simply 2y. So d by dx of tan square x is 2 into tan x. Now you have to differentiate tan x also. That is chain rule. So now 2 tan x, and again differentiation of tan x is sec square x. So sec square x, and this is going to be 2 tan x sec square x. Okay. So this is how it is done. Okay, this question, this is simple question which we already saw in the first part. But the only catch here is, if you take d by dx of tan x, it will be sec square x. But we have a degree here, and we don't differentiate when it is degree. We always convert it into radian. So you need to convert first it to radian, and then you have to differentiate. Because 180 degree is equal to pi radian, or pi radian is equal to 180 degree. So in order to convert a degree into radian, you have to multiply it by pi by 180. Alright? Because 2 pi is equal to 360 degree. Pi radian, 180 degree. 1 degree, pi by 180 radian. So tan x degree plus 45 degree, whatever value comes, that has to be multiplied or converted to radian by multiplying it by pi by 180. Now you can differentiate it. You can only differentiate when you convert first. That will be used in other questions also. So you need to keep this in mind. So first thing is tan theta is sec square theta. It's sec square theta. And then we have x plus 45 degree. This is not degree. X plus 45 pi by 180 because it is radian. So sec square theta. Then you have to differentiate the inside one also. That is chain rule. So this d by dx of x plus 45 into pi by 180. You don't write degree now because you have already converted it. What is the differentiation of this? You can assume it to be x into pi by 180 plus 45 into pi by 180. So d by dx of this and d by dx of this. See, this is whole constant, so it is going to be 0. This x into pi by 180, so pi by 180 will come in front. D by dx of x, that is d by dx of x is 1. So pi by 180 it will be. And that pi by 180 has to be written in front. So this is your final result. So finally the result, because the question is given in the degree, so you have to convert this into degree. Not you just don't leave it like pi by 180. You have to write it in degree. So it will be x degree plus 45 degree of sec square pi by 180. Sine log x. So first you have to differentiate, assuming it to be sine theta. Then the next one will be to to differentiate the log x. Alright. So this sine x differentiation is simple cos x. So cos log x it will be. Theta is log x we have assumed, right? So cos log x. Then you have to differentiate log x because the chain rule. You will keep on differentiating until nothing is left. So d by dx of log x is going to be what? Log x differentiation is 1 by x. 1 divided by x. You can see the standard result also here. The 12th one I am showing you. This 12th and 15th, because if the base is E or the base is A, it behaves differently. So cos log x, d by dx of log x is going to be 1 by x, and that is going to be your final result. This is going to be your final result. Please remember standard result and also then chain rule. These are the two things you need to take out from this discussion. First, assume it to be just theta. Then you have to differentiate whatever is theta. And if it is log x square, you have to differentiate log x square, then x square also. So step by step you have to go till the time nothing is left to be differentiated. This is e to the power sine root x, e raise sine root x. And ex, assume it to be e theta or e to the power y. The differentiation of e to the power x is simply e to the power x. There is nothing, no change. Whatever is different, you are differentiating, you just have to write that. So e to the power sine root x, the differentiation of this d by dx of this whole expression or term will be same thing, e to the power sine root x. Then you have to differentiate sine root x. What is sine root x? Again, assume this root x to be theta. So sine theta is cos theta, d by dx of sine theta is cos theta, so cos root x. Then you have to differentiate root x. D by dx of root x is what? 1 by 2 root x. Now this result you know already, because this d by dx of root x is 1 by 2 root x. How has it come? You just see here or assume this not to be root but x to the power half, because it is actually x to the power half. So just apply n x to the power n minus 1. So half x to the power half minus 1. Half minus 1 is negative half. So this negative half to x to the power negative half is 1 by x to the power half, that is going to be root of x. So 1 by 2 root of x, that is how it has come. So final, you have to combine all these results. First was e sine root x, then you have cos root x, then root x was 2 root x, 1 by 2 root x. So this whole is the result of this differentiation. differentiate e to the power 10x. Same thing, because e to the power something, differentiation will be same thing, nothing will change. So d by dx of e to the power 10x, e to the power theta, whatever you call, is same thing, e to the power 10x. Then you have to differentiate 10x. d by dx of 10x is sec square x. So it is going to be sec square x and e to the power 10x. You can write whichever you want, first or second, but it is always advisable that those terms, because here you see everything is getting say intertwined. So in order to just differentiate them, we have written sec square x first and then e to the power 10x later. Differentiate sine square 2x plus 1. Again, it is sine square of something. Assume it to be say some x square or y square. So sine 2x plus 1, it is whole square. Assume that you are differentiating something, say y square. So d by dx of y square is 2y to the power of 2 minus 1. And x to the power n minus 1 I am applying. So it will be 2 sine 2x plus 1 and 2 minus 1 is same thing. So 2 sine 2x plus 1 it will be. And then you will not stop here. You have to differentiate 2x plus 1 also. So no, sine differentiation first, then 2x plus 1. So d by dx of sine theta is cos theta. So it will be cos 2x plus 1. Now the third chain, because 2x plus 1 is still in the chain. So you will differentiate d by dx of 2x plus 1. And how to write this? D by dx of 2x plus 1 is 2 into d by dx of x plus d by dx of 1. d by dx of 1 is 0, constant is always 0. And then 2 comes out, d by dx of x is 1. So this whole result will come. Okay. Now there is one more thing. You will not stop here. Because if this differentiation gives you or it points to some standard result, you will use that result, because sine 2 theta is 2 sine theta cos theta, which you see here also. So this 2 sine theta cos theta will be sine 2 theta. It is going to be 2 we have employed, so only 2 will be remaining. The 2 sine 4x plus 2. Log base 7 2x minus 3. Log of e base is 1 by x, but when you have log base a, that is some constant base is there, not e. Standard is e, which we write as ln. But when we write log with some base, say here base is 7. Log base 7 2x minus 3. So we will use the standard result. This is log base a and x. So d by dx of log base a x is nothing but 1 by x and then log base e a in the denominator. So log base e a, you don't have to write base e again and again. It's understood. So log base 7 2x minus 3. In this case, a is 7. You can just compare this with log base ax. A is 7, x is 2x minus 3. You can just write it here, 2x minus 3 here, log base e, a is 7. Alright? But you will not stop here. You don't have to write e because it is log base e. But you will not stop here. You have to differentiate 2x minus 3 also. And 2x minus 3 is simple. 3 will be 0 and 2x, 2 comes in front, d by dx of x is 1. So d by dx twice of d by dx of x, that is going to be 1. So this is 2 by 2x minus 3, log base is log 7, you can just write. So this is your final result, 2x minus 3 log 7. Don't write e because it is understood here. Differentiate tan 5x degree. Same thing you have to do. You cannot differentiate when it is in degree. You need to convert the degree into radian first. Then you can differentiate and final answer will not be in degree. Please remember. So this is tan 5x, pi by 180 you have to convert. Alright. So tan we have already seen. Tan x is sec square x. So you can just write whatever is inside, doesn't matter. You just write sec square and whatever is inside just put it here. 5x and pi by 180. Now degree we have converted into radian now. Then only you can differentiate. But now 5x into pi by 180 is also remaining. Chain rule. So 5x into pi by 180, differentiation of that will be, constant will come out. So 5 pi by 180 will come out. And d by dx of x is going to be 1. So only 5 pi by 180 will be there. But if you write 5 pi by 180 in the end, it will be seen as, okay, this is following sec square 5x pi by 180 and 5 pi by 180. So you always write constant in the front. So 5 pi by 180 is sec square 5x degree. Always remember, you have to write in the degree. Differentiate 2 raise x cube. So 2 to the power x cube you have to do. So this is almost related to a to the power x kind of formula. And what is the differentiation of d by dx of a to the power x? It is going to be a to the power x log base EA. So d by dx of a to the power x is a to the power x log base E and then a. Now try to similarize or try to compare this with 2x to the power 3 with a to the power x. A is 2 here and then x is x cube for just now. It is not 3 to the power 3, it is x cube. So it is 2 to the power x cube and then log base E. What is a? 2. But you will not stop here. You have to differentiate x cube also. So x cube will be 3x square. This is a standard result. Because of the formula we already know. But because of the chain rule, you have to differentiate x cube as well. So d by dx of x cube is going to be 3x square and x to the power n minus 1. But you always write this in the front. So 3x square multiplied by 2x cube log base E 2. Don't write base E. It's understood. Differentiate 3 into e to the power x. Same thing you have to do. Same a to the power x version you will use. This is 3 e to the power x, and as I told you here also, this is almost same. So log a to the power x log EA will be the differentiation of a to the power x. Now first compare what is a here. So d by dx a to the power x is, as I said, a to the power x log EA. So a to the power x is simply this thing, just you can replicate it. What is a here? 3. So now you just apply it here. X is e to the power x. So 3 e to the power x log base E. You can just skip E. This a is 3. But this you cannot stop here. You have to differentiate e to the power x also. D by dx of e to the power x is e to the power x. That is going to be a final answer. And always keep this e to the power x in the front. You have to write exactly like this, everything, in writing. I'm not writing it just to save time. Differentiate log base is x 3. So in order to solve this, there are certain ways, like directly you can use the expression, but the problem here is the x is in the base. So you cannot directly differentiate it. So you need to convert it in the way so that you can differentiate it. For example, the property of log base AB can be written as log B by log A. And this is a property because you can convert the log to base E, then only you can differentiate. Right? So how do we write this? Let me write it like this. Y equals log base is x and then 3. So you can always write it as log 3 by log x, the way I told you just now. So when you differentiate it, d by dx, log 3 is constant. Log 3 you don't need to differentiate, you can just take it out as a constant. Then d by dx of log x, now you can just assume it to be some z or y. When it goes up, log x goes up, y goes up, it will be negative power. So log x to the power minus 1. Now you just differentiate according to, say, x to the power n. The power is negative 1 here. So nx to the power n minus 1. So you have a log 3 here. -1 comes in front, log x to the power -1, that is n minus 1, -1 minus 1, that is -2. So you have a negative here, then you have a log 3 here. In the denominator, this log x, when the square -2 goes in the denominator, it will be log x whole square. Alright. Now log x is also remaining. So log x is 1 by x. So are we done? No. Because the log base x 3, now we have converted into certain things which we need to, make it the way we have started. So we can multiply and divide log 3 log 3. So the numerator will be log 3 whole square. This two terms, log 3 and log x, how can we write? If I take log x and log 3 in the denominator, I am taking log 3 in the denominator because ultimately it is in the numerator. So this is negative, 1 by x is already there, log 3 is also there. Now log x and log 3, because we started with this only. Alright. So you have to convert it into the way we have started. So log x by log 3 was actually 1 by log and base 3 x, and then this is x log 3. Now we have a x with log, not the base. So those who want to do it by themselves, they have the option, or you can write it also. But the way you have to do is, I explained you just now. So we will be using chain rule, we have been using chain rule, we'll be using the product rule and the quotient rule, all those. But in order to solve all these differentiation questions, this log property and the chain rule property and the other properties you need to understand and know prior to attempting to solve these questions. Next one is 3 raised to the power x square plus 2x. So this is 3 raised to the power x square plus 2x. Just assume it that there is some 3 and there is something over it. Let us call it as z. So when you differentiate it, it will be something a to the power x phenomena. So a to the power x will apply. What is a to the power x? If you compare it with a to the power x, a is 3 and x is your x square plus 2x total. So you have 3 to the power x square plus 2x, then log, then base is e, and then you have a is 3 here. But our work is not done. You have to take this x square plus 2x and then you have to differentiate it as well. So d by dx of x square plus 2x, again n to the power x, this n to the n x to the power n minus 1. So d by dx, you can just separate them. So d by dx of x square twice of d by dx. So d by dx of x is 1 only, so there will be 2 only remaining. X square is 2x. You want to keep it like that, you want to write it as 2 into x plus 1, it is up to you. Both are agreed upon. Now, so what is the final answer? What we got? 2x plus 2. And what did we just do just now? 3 into x square plus 2x and log base e3. You can just relieve yourself from writing the base always. If you are just writing log, that is assumed that the base is already e. So the way you have to write in your examination is, I have provided you the solution also and the explanation also. If you just want to skip, you can just skip, because that is why I give you these answers. Because the understanding is also important, but sometimes people don't want to understand all the question. They know most of it. This type of questions we'll be solving a lot in this exercise. So you need to understand what we are doing here, because there are series of questions we will be attempting. In order to solve this question, this is total algebra, I am telling you. If you know the differentiation result, it is quite easy, but the algebra part is very cumbersome. It takes a lot of time, and there are always chances of some failure or problems. So this is under root. Under root. There is a rule which I already uttered. So we have a quotient rule. Quotient rule. So we can have a scenario when we have numerator and denominator, and that has to be divided, differentiated. So just assume this is y. So in order to differentiate it, what do we do? A square minus x square, a square plus x square, and root is nothing but to the power half. The power half is nothing but under root. So in order to differentiate this, first you have to assume this whole a square minus x square plus a square plus x square as something which is, say, z or y or whatever. Don't call it k, because k is always used for some constant. So better is to, x, y, z is better to understand that we are dealing with the variables. So half x to z to the power half minus 1, half. So z to the power minus half. So when you take z to the power minus half in the denominator, it will be z to the power half. That is, the actual content which you see here will be inverted when the differentiation of this is done. First step. So z, when it is taken in the denominator, because it is z to the power minus half, that is what we got. But we don't know how to write this z to the power minus half. We have to take it in the denominator. So that z to the power half you have to write. And the z to the power half is root of the content, but it is inverted. So a square minus x square and a square plus x square in the denominator. So it will go up. A square plus x square will go up and a square minus x square will be in the denominator. I hope you got this idea. Right? But now the actual chase or run starts. We have to differentiate this one. And here I was talking about the quotient rule. Assume that you have a u, which is a square minus x square here. V, which is a square plus x square. You want to differentiate this u by v. This is numerator, this is denominator. So the quotient rule says, first concentrate on the denominator. It is the denominator, you have to square it. So v square, no differentiation up till now. Write the denominator and differentiate the numerator. That is v d by dx of u. Subtract the numerator and differentiation of the denominator. That is the final result. So a square plus v is nothing but, you know what is u and v now. Huh? U is a square minus x square and v is a squared plus x square. So v is what? This is u, this is v. So a square plus x square is your v. D by dx of u. What is u? A squared minus x square. A is a constant, x is a variable. So when you divide it with respect to x, a square will be 0 and x square will be 2x, negative of 2x. So you can keep it here, minus 2x. There is a negative sign here. U, you can just write it like that. U is a squared minus x squared. And d by dx of a square plus x square, same result with 2x, means positive sign. So a square will be 0, x square will be 2x. Alright. So in the denominator, it will be square, no differentiation. So a square plus x square to the power of square, whole square. Now let us use the algebra, the normal way we have been doing till this standard, this class. So minus 2ax a square, I'm doing the numerator right now. I'll be writing the denominator just now. But let us see the numerator first. Minus 2x into a square. Minus 2x into x square, that is minus 2x cube. And then minus 2x a square. Then minus minus become plus. So it is 2x into x square, x cube. So this gets cancelled. You have minus 4x a square. See, this is already remaining. This is already there. We have taken the chain rule. So we are differentiating the other part. So half under root a square plus x square, you can always write it as 1 to the power 2. That is half. And denominator also you can write a square minus x square to the power half. But I don't want to write it because I have to deal with a square plus x square to the power 2. I'm just saying under root a by b is under root a by under root b. Under root a I am writing it as a to the power half, and b I am keeping it in the root. And minus 4x a square, you can just write it here and cancel whatever is, you can cancel. So this is minus 2x a square. That is minus 2a square. In the final answer, this is going to come. So just keep it like that. Now, this one, this is under root a square minus x square. Now, why I did this a square plus x square to the power half? Because there was a square plus x square in the denominator square. Remember, we just applied the quotient rule. So I will be taking this a square plus x square to the power half in the denominator. So it will be a square plus x square to the power minus half. So 2 minus half is what? It is 4 minus 1 by 2. So it is going to be 3 by 2. So in the denominator, you will get what? It is a square plus x square to the power 3 by 2. Numerator was already there, I told you already. So minus 2a square x. So this is your final answer. You can just verify and write it like this. Next is 3 to the power x log x. 3 is there, x log x is there, log x is also there. So there are multiple, you can say, steps you have to go. So those who want, they know or how to do it, they can just check it here. Want to write, they can write it here. Those who want to understand, just go with me. So d by dx of 3 to the power x log x. See, this exercise has a lot of questions, more than 70. So if you know it, just skip. And those who want to understand, because there will be repetition of questions. Same question will come multiple times. So we have a to the power x log ea. So 3 to the power x log, base is e, and then a is what? 3. So the first step in the differentiation is applying the d by dx of a to the power x. Alright. So now I am comparing. See, this is I am comparing 3 to the power x log x with a to the power x. A is 3, x is x log x. So just use this formula, and this is the first step as I just indicated. So it will be a to the power x, 3 to the power x log x, and then this is log e a, log base e and 3. So this differentiation, but we have x log x also. So we will apply another rule. In the previous question I told you about the quotient rule. Here we have the product rule. D by dx of x log x. X is a different function, log x is a different function. So in order to differentiate them, x and log x, we have to use the chain rule. We have to apply. That is a de facto work. But d by dx of u into v, that is the product rule. U, then d by dx of v, then d by dx of u. And you can just change them whenever you want. It doesn't matter. So x log x, I'll do it here. And then I'll combine it with the final answer. So d by dx of x log x, take x, then d by dx of log x, then you take log x, and then d by dx of x. So x, d by dx of log x is 1 by x. So x by x plus log x, d by dx of x will be 1. And this x by x cancelled, 1 plus log x will be the final result. Alright. So what actually came? 3 to the power x log x. And log 3 with base e, and x log x was 1 plus log x. So we applied the chain rule, we applied the a to the power x, and we applied the product rule also. Differentiate under root 1 plus sin x by 1 minus sin x. Remember I just told you that this kind of questions are going to come a lot. So if you just assume this to be, say, this whole content inside the under root as z. So root of z will be simply this. Basically, it is a power of half only. So half z to the power half minus 1. So half z to the power minus half. So z will come in the denominator. So 1 by 2 under root z. But since this content will come in the denominator, when you write it properly, the 1 minus sin x will go in the numerator, 1 plus sin x will come in the denominator. That is how we normally write. But when we take this in the numerator, 1 minus sin x, it is going into the numerator. 1 by 2 into under root 1 plus sin x will remain here. And under root 1 minus sin x will go up. Alright. Now, what to do? Are we done? No, because we have just done the first step. Now you have to differentiate 1 plus sin x by 1 minus sin x. Now this is the point we have already come. Those who are doing by themselves, I just showed you the answer. And for those who have come to this step, now the next one is to differentiate the inside stuff. And we have to apply what? The quotient rule, u by v form. What form? U by v. So d by dx of this will be 1 minus sin x will be in the denominator with a square, because the formula I just told you. So 1 minus sin x whole square. 1 minus sin x will come first. Then the differentiation of 1 plus sine x, d by dx of 1 plus sine x. Then you have a sign, negative sign. Then you have 1 plus sine x and differentiation of 1 minus sine x. Okay. So d by dx of 1 minus sine x, 1 plus sine x and 1 minus sine x. 1 is 0, sine x will be cos x. D by dx of 1 minus sine x will give you minus cos x. So 1 minus sine x, d by dx of 1 plus sine x is cos x. Then minus, you have 1 plus sine x, just write it like that. And d by dx of 1 minus sine x will be, d by dx of 1 is 0. And negative will come just like that, sine x is cos x. So you have a negative cos x, minus cos x. So you have a minus cos x, and you can just presume, I've just changed the sign, that something is going to be cancelled. So this will be cos x minus sin x cos x, or cos x sin x you can write, plus cos x plus cos x sin x. These two gets cancelled. In the numerator you get 2 cos x. Okay. 1 minus sin x whole square in the denominator. So you have come up till here. Are we done? No, not yet. Because we cannot keep the content like this. You have to minimize it to the level where your mind can think. The examiner wants you, or the question maker wants you to go to the extent you know everything. So we'll try to do something here. First thing is 1 minus sin x whole square is in the denominator. 2 cos x is in the numerator. So under root 1 minus sin x in the numerator is to the power half. I am taking it in the denominator. So 1 minus sin x, the half, when we brought it down to the denominator, it will be minus half. So 2 minus half, they will be added. This 2 I am cancelling. In the numerator it is going to be cos x. In the denominator you have under root 1 plus sin x. You can keep it like that. And in the denominator, as I said, it will be 1 minus sin x. And this is power 2, and minus half, that is power 3 by 2. Now 3 by 2 you can write it like this. 3 by 2 is 1 plus 1 by 2 only. 3 is 1 plus 1 by 2. So this 1 minus sin x to the power 3 by 2, I am just telling you the denominator. This content I am not writing. Only the remaining I am writing. So this is under root 1 minus sin x, which is actually, let me write it first. 1 minus sin x to the power 1 and 1 minus sin x to the power half. Okay. So this 1 minus sin x to the power half will be under root 1 minus sin x. It is under root. And this is 1 minus sin x. Okay. Now under root 1 plus sin x was already there. So if you write under root 1 plus sin x, because under root, the content goes inside and they can get multiplied. So under root 1 minus sin x into 1 plus sin x is what? 1 minus sin square x. A minus b, a plus b. Multiply a square minus b square. So 1 minus sin square. So 1 plus sin into 1 minus sin is going to be a square minus b square, 1 square minus sin square. So it is 1 minus sin square. And we know that cos square plus sin square is 1. So 1 minus sin square is cos square. So it will be cos square. And when you take this root out, it will be cos x only. So cos x is in the numerator. This one already we have multiplied, and whatever is remaining, cos x was there. Cos x is this one, numerator. And cos x came in the denominator also. And 1 minus sin x is remaining. This is remaining. 1 minus sin x. Now you have another question. 1 by 1 minus sin x, are we done? No, up till now we are not done. We will not leave it here. You can leave it here. I don't know what, you will get whole marks or whatever, I don't know. But the extent you can go, you have to try. So multiply it by 1 plus sin x and 1 plus sin x. I am simply rationalizing it. So 1 plus sin x in the numerator, you have 1 minus sin and 1 plus sin. We have already done that. That is going to be 1 minus sin square x. That is going to be cos square x. Cos square, you can write it here. Now you can separate them. 1 plus cos square plus sin by cos square. 1 by cos square is what? Sec square x. Cos square x, 1 by cos square x is sec square x. sec square x. 1 by cos square x, sec square x. Now you have sine by cos. Sine by cos is 10. So 1 cos will remain in the denominator. It will be sec x. So this sine by cos square is nothing but tan x and sec x. You can write it like this, sec x and tan x. Now you can take sec x common. Take the sec x common. You have sec x remaining for the first term, and the second term is going to give you tan x. This is your final answer. And those who know more than that, you can apply that also. We will be stopping here. Differentiate under root 1 minus x square by 1 plus x square. So in this differentiation, we assume first, because we need to apply the chain rule. So we assume that something is inside the under root. We are assuming it to be, say, y equals under root z. Now this z, this will be differentiated later on until there is nothing left for differentiation. For example, if you want to differentiate this, imaginary y equals under root z, it will be 1 by 2 under root z. You know that under root of x, the differentiation is 1 by twice of under root z. Okay. Then we differentiate this z. And z is what? dz by dx. So this is 1 by 2 under root. Now this is in the denominator. Whatever is in the equation has come in the denominator now in the first step. Basically it's 1 by under root 1 minus x square by 1 plus x square. This goes up. Under root 1 plus x square goes up, and under root 1 minus x square goes in the denominator. So this is 1 minus x square in the denominator under root, and the same thing under root will be in the numerator. But we still have to do this differentiation of 1 minus x square by 1 plus x square. So d by dx of this u by v form is v square in the denominator, v d by dx of u minus u d by dx of v. Means you can just see that u has to be in the numerator, v is in the denominator, then we follow this kind of quotient rule. So d by dx of whatever is inside, we are just calling it as z, and we will use this. This first part is already done. Now we are differentiating the content inside the root. So 1 plus x square to the power whole square will be in the denominator. 1 plus x square now. Then d by dx of 1 minus x square it will be. So this is going to be 0 minus this is going to be 2x. So negative 2x it will be. Then minus 1 minus x square and d by dx of 1 plus x square. So same thing with a positive sign. 1 minus x square, 1 plus x square, it will be 2x only. Okay. Now you can just open this in the numerator and see what comes. Minus 2x and minus 2x cube. And here we have minus 2x and plus 2x cube. So this minus 2x cube and plus 2x cubes gets cancelled. Minus 2x and minus 2x will give you minus 4x. In the denominator it is 1 plus x square by whole square. And this was already there, which I just rounded up. This was already there, 1 by 2. So 1 plus x square, you can write it as 1 to the power half. So root is nothing but 1 plus x square to the power half. And denominator 1 minus x square to the power half, or you can just keep it like under root only. Now in the previous question, one of the previous question we have done this. So 1 plus x square to the power half, I am taking it in the denominator. This minus 2x, which I cancelled 2 with 4, and denominator under root 1 minus x square, I kept it like this. And this half power has come in the denominator. So 2 minus 1 by 2, the power gets added. It is going to be 3 by 2. So this is your final answer. Differentiate log sin x whole square. So we have y equals, say something x square, z square, or whichever you can assume. The differentiation of x to the power square is 2x. If you assume it to be some x square or z square or whichever. So d by dx of log sin x whole square is twice of log sin x. Now you have to differentiate log sin x. D by dx of log sin x will be done now. And d by dx of log something is 1 by of that something. So 2 log x sin x, d by dx of log sin x is going to be 1 by sin x. And then differentiation of sin x is what? We are doing chain rule. Cos sin x is cos x. So cos x by sin x is cot x. So the final answer will be 2 log x sin x cot x. Cos x sin x, we are writing it as cot x. 2 log x sin x. So log sin x is one term. Cot x is another term. This is your final differentiation. These are the differentiation result we have used. Now differentiate under root 1 plus x by 1 minus x. So we have just done a question 1 plus x square and 1 minus x square. So we have done a more complicated version. So I hope you will be able to do it. The answer is in front of you. You can try any problem, you can just ask. Okay. So this is the same, one of the same question we have already done. And this is also a kind of that type of question only without a root. But the idea will remain same. So we'll do this. Sine of something. So y of sine of something, this you can call it as, say, z. The sine of something is going to be cos of that thing. That thing, call it as z or whichever character you can want. So d by dx of this sine theta is cos theta. Now the theta or z or whichever you are asking, you have to differentiate that as well. So cos of 1 plus x square by 1 minus x square. Now d by dx of 1 plus x square by 1 minus x square also has to be done. So d by dx of 1 plus x square by 1 minus x square. And we will apply the quotient rule as we have applied in the previous questions. So in the denominator it will be 1 minus x square to the power square. Then 1 minus x square will come here. D by dx of 1 plus x square, that is 2x, minus 1 plus x square, it is d by dx of this 1 plus x square. 1 minus x square, sorry. It is going to be minus 2x, so I change the sign in between. Okay. So let us multiply this. 2x you can take common. 1 minus x square plus 1 plus x square will come. X square gets cancelled. And 1 plus 1 is 2. So 2 into 2x is going to be 4x. So the numerator will be 4x. 1 plus 1 is 2. So this is going to be 4x divided by 1 minus x square and to the power whole square. So 1 minus x square to the power whole square. And here I'll just write the square, okay, in the denominator. So cos 1 plus x square by 1 minus x square. This is going to be your final answer. This is 1 minus x square whole square in the denominator. Please remember. Okay. So this kind of differentiation, and we have used the normal version and then the quotient rule and the chain rule. Differentiate e to the power 3x and cos 2x. So there are two separate functions. One function you can call it as fx, the other function you can call it as gx. So when you differentiate these two functions with fx into gx, please remember d by dx of cos theta is minus sin theta. E to the power x differentiation remains the same. There is no change when you take the differentiation. So one is fx, one is gx. So fx will write e to the power 3x, that d by dx of cos 2x, cos theta is minus sin theta. So you have minus sin 2x. Now you have to differentiate 2x also. You cannot leave 2x. Differentiation of 2x is 2. Right? Then we have subtraction. And this, I know that the differentiation will give you something like that. So cos 2x, e to the power 3x and then 3x also. Okay. So when you see the result here, it's going to be e to the power 3x. You can take common. So this you can write first, 3 cos 2x and minus this 2 sin 2x. So here this product rule we have applied the chain rule. So and we know the differentiation of e to the power x and cos theta. So 2x and 3x, they both also have to be differentiated as per the chain rule. Differentiate sine of log sin x. Sin x, the differentiation is cos x. Log x, the differentiation is 1 by x. So y equals sine. So whatever is inside, call it as z by just for now. So dy by d of x or z, sin x will be cos x. So cos log sin x it will be. And then differentiation of log sin x. In chain rule, now you have to differentiate the log sin x. So d by dx of log sin x will be, because log x is 1 by x. So log sin x will be 1 by sin x. Whatever is inside log, it is going to be in the denominator. So this is 1 by sin x. Now you will not leave it here. The differentiation of sin x, because the chain rule you are following, the differentiation of sin x is going to be cos x. And cos x by sin x, you can write it as cot x. So the final result will be cot x cos log sin x. Okay. This is your final result. So cot x cos log sin x. And the way you have to write, because it can be your exam, it can be your classwork, all these English you have to represent. The basic is that you might be knowing how to solve the question, but you have to describe it to your examiner that I know how to solve it. So the maximum you will write, the maximum you will say represent. For example, your IQ may be 90 or 900, but the person who has IQ of 70 and who writes very well, who represents very well, is far better than the person who is having a very high IQ. Because having mind and not able to represent it, what you know, is equivalent to a person who knows little but he can explain better. That is why I always show the answer. This is because ultimately you have to answer. Differentiate e to the power tan 3x. So e to the power x, the differentiation will be e to the power x only. So e to the power z, differentiation will be what? E to the power x only. So e to the power tan 3x it will be. Now what is the differentiation of tan 3x? Because you have to use the chain rule. D by dx of tan 3x is, tan theta is sec square theta. So it will be sec square 3x. So e to the power tan 3x, sec square 3x, and then the differentiation of 3x. And it is 3 only. So you can write either way you want, but just write the answer so that the 2 or 3 terms, they do not seem to be combined, or you cannot differentiate. So the better is to 3 e to the power tan 3x and sec square 3x. Alright. So whatever you are applying, you just write it here. If you see in the answer, the product rule or this is not written. You have to write it there properly. E to the power under root cot x. So this, I think this kind of question we have already done. So e to the power x is simply e to the power x. So e to the power under root cot x will be e to the power under root cot x only. First differentiation, first step. So e to the power z, e to the power under root cot x. Now you have to differentiate under root of cot x. So assume it to be under root of z or something. So d by dx of this under root of something is 1 by 2 root under root something. It will be 1 by 2 under root cot x. This one, okay. So it is basically cot x to the power half. So when you differentiate it, it will be half into cot x to the power half minus 1. That is half into cot to the power minus half. Minus half goes in the denominator, and that will give you under root of cot x. Twice of root cot x in the denominator. Okay. Now the third step is cot x. You have to differentiate cot x. Cot x is minus cosec square x. This is a standard rule. So final answer is 3 terms. E to the power under root cot x, which we got just by saying e to the power theta kind of differentiation. Then we took the under root cot x, which got us twice of under root cot x. and then the minus cosec square x, which has come from differentiation of cot x. So wherever you are doing chain rule or differentiating or final result, each has to be written in the way which has been prescribed here. And you know the differentiation of whichever element, whichever term, whichever identity, trigonometry or algebra. This also you have to write, and making a round, or you can say making a square around it will always be welcome. Differentiate log sin x divided by 1 plus cos x. So we will apply first the normal thing, that is log theta, 1 by theta. Then we have to apply the quotient rule, because we have to differentiate sin x by 1 plus cos x. So y equals log of something, it is going to be 1 by of something. So this sin x by 1 plus cos x will come in the denominator. So 1 plus cos x will go in the numerator. So it will be 1 plus cos x by sin x. Okay, differentiation of log x I am saying. So this term we have already achieved. Now the second will be to differentiate sin x by 1 plus cos x. And differentiation of sin x by 1 plus cos x, that is u by v form. And this is going to be a quotient rule. Log x is simply 1 by x, which I already told you. And the answer also we got of this thing, 1 plus cos x by sin x. So in order to differentiate this, assume this sin x to be u, 1 plus cos x as v. So sin x by 1 plus cos x, u by v. You see on the right, if you are able to write this quotient rule to the examiner, then also it will be very well appreciated. So 1 plus cos x in the denominator square, 1 plus cos x here, d by dx of sin x will be cos x only. And then we have a subtraction sign. Then we write the sin x like that. And 1 plus cos x is going to be, 1 will be 0, cos x will be minus sin x. Okay? Cos x is minus sin x. So just change the sign, write a sin x here. So you can call it as sin square x. Now you see in the numerator, I am not writing the denominator. Let us solve the numerator first. So cos x into cos square x plus sin square x. Now cos square x plus sin square x is what? It is going to be 1. So replace it by 1. So you get 1 plus cos x. So 1 plus cos x it will be. And in the denominator you have 1 plus cos x whole square. So you can cancel one of it. So in the denominator you have 1 plus cos x. And this is 1 plus cos x by sin x. It was already there. So 1 plus cos x by sin x. Now you can just cancel this 1 plus cos x and 1 plus cos x. So 1 by sin x will come. And 1 by sin x is what? It is cosec x. It is going to be cosec x. So this is your final answer, cosec x. So write that you have used the chain rule and the quotient rule. And if possible, also write the quotient rule, if possible. Okay, now these are all the combination possible. So log of theta, then you have theta in the root, and then you have inside that you have another term, 1 minus cos theta by 1 plus cos theta. So those who have already done and they just want to go ahead, they can just refer to the answer and just try solving themselves. So then those who want to learn or understand, let us see y equals to log z. Log z, this whole root is the log z. So it will be 1 by under root of 1 minus cos theta by 1 plus cos theta. So 1 plus cos theta under root will go up, and under root of 1 minus cos theta will be in the denominator. So 1 plus cos theta in the numerator, 1 minus cos theta in the denominator. Alright? This is the first step. The second step is to do the differentiation of under root. So the under root is what? Under root, if under root theta you have to, or under root x you have to differentiate, it will be 1 by twice of under root of that content. Okay? This is just 1 log x. Log x is 1 by x. So this just we have got the first step. Now we have to do or differentiate the under root of 1 minus cos x by 1 plus cos x, assuming it to be just root of something. And root of something is 1 by twice of this content. So 1 minus c, 1 plus c, 1 minus cos theta, 1 plus cos theta to the power half. So half will come in front, and 1 minus c by 1 plus c to the power half minus 1. That is half minus 1 is negative half. And it will come in the denominator. 1 minus cos and 1 plus cos come in the denominator. Okay. So this is going to be 1 minus cos, and 1 plus cos will go in the numerator. But this will be in the denominator with the root. Okay. So let me write it all of it. 1 plus cos in the numerator, 1 minus cos in the denominator, and we have a 2 in the denominator. Under root 1 plus this one, under root 1 plus cos will go in the numerator. This 1 minus cos will be in the denominator, and 1 by 2 of course, as I said. Now under root of something with under root of something, same thing is going to be, the under root will be eliminated. And since we have this 1 plus c, that is 1 plus c whole square, 1 plus cos theta whole square. This under 1 plus cos into 1 plus cos, the under root it will go inside. It will be 1 plus cos square, and under root this gets cancelled. So 1 plus cos, and same in the denominator. Under root 1 minus cos, under root 1 minus cos, under root get cancelled, because 1 minus c square it will be if you multiply inside, and 2 will be cancelled with 1 by 2. So finally we got 1 plus c by 1 minus c. C is of course cos theta. But this is just a second step. Now you have to differentiate 1 minus cos theta by 1 plus cos theta. This also you have to do. So we will apply the quotient rule, QR. So 1 minus cos theta by 1 plus cos theta. So we have 1 plus cos theta in the denominator, 1 plus cos theta it is. And then differentiation of 1 minus cos theta. So let me do it here, d by dx of 1 minus cos x. So 1 will be 0. Cos is minus sin theta. Negative is already outside, so it will be positive sin theta. Cos theta is minus sin theta. Please remember, sin theta differentiation is cos theta, and cos theta differentiation is minus sin theta. Alright? So you just have to write sin theta here. So let me write sin theta. I am taking the short form. 1 minus cos, and then we have 1 plus cos. Differentiation of 1 plus cos is what? Cos theta is minus sin theta again. Okay. So minus gets plus here, and then we have again a sin theta. Now just open this, or you can take sin theta common, 1 plus cos and 1 minus cos. Cos gets cancelled, you will get 2. So 2 into sin x, you can see here also, or you can just open it. 1 plus sin into cos plus sin, sin plus sin cos plus sin minus sin cos. So this sin cos gets cancelled. 2 sin x in the numerator, and 1 plus cos whole square. Now write it here, 2 sin x, 2 as I am writing sin, s for sin and c for cos. So 1 plus c, this goes out, cancelled, 2 gets cancelled. So you have in the denominator 1 minus c and 1 plus c. So you have a sin x in the numerator, and 1 square minus c square, a plus b, a minus b. 1 minus c square is 1 minus cos square theta is sin square theta. So just write sin square here, just cancel this sin and sin square. 1 by sin square is 1 by sin x in the denominator. It is going to be cosec x. So this is your answer. Cosec x will be the final answer. Okay. Differentiate tan e to the power sin x. So this is first step will be to assume it to be some tan theta or tan y. So we have y equals tan say theta. So dy by d theta will be the differentiation of tan theta. So tan theta differentiation direct value we know. So on the left I have given you. If you just want to skip, you can have a look and if you're comfortable. Otherwise you can just follow me. Tan theta is sec square theta. Now this is going to be sec square theta is what? E to the power sin x. Now what is remaining? E to the power sin x, because we have to apply the chain rule. So this whole sec square e sin x, this is already done. Now e sin x we have to differentiate, because e to the power x is e to the power x only. E to the power sin x will be e to the power sin x. Now sin x. What is the differentiation of sin x? It is cos x. So what we got? The first one was sec square e to the power sin x. The second was e to the power sin x, and third was cos x. So 3 step we went and we employed the chain rule, and this is your final answer, right? So you have to go till the limit. Differentiate log x plus under root x square plus 1. So assume it to be y, say, first, because we have to do the log something. So assume it to be, say, z. So dy by dz, if you want to do, log z is simply 1 by z. And what is z? X plus under root x square plus 1. So this is the first step. Now this is done. Log is eliminated now. Now you can concentrate on x plus under root x square plus 1. So we'll do this one because this is the chain rule. A d by dx of x plus under root x square plus 1. Alright. So what is the differentiation? This remains like that. D by dx of x is going to be 1. And whatever is inside it, a root, it will be 1 by 2 root and means 1 by 2 under root of that thing. So 1 by 2 under root of what? X square plus 1. Now x square plus 1 also you have to differentiate. So x square plus 1 will be 2x plus 0. So 2x it will be. So you just can cancel these 2 out. So 1 plus x by under root x square plus 1 it is. It is under root x square plus 1. So you can just take this first one and the second one. If you see, we can add this and there will be a cancellation. This first content was already there and this we can add. That is 1 by x plus under root x square plus 1 is already there, which was the first when we got from log. And this under root we can add 1 plus x by under root x square plus 1. This is going to be under root x square plus 1 and plus x divided by under root x square plus 1. Alright. So now we can just cancel these 2 out, x plus under root x square plus 1. So this one and this one can be cancelled. You have 1 by under root x square plus 1. This is your answer. 1 by under root x square plus 1. Now this one, this will be done using the quotient rule. So assume u and v, numerator, denominator. So you have to do d by dx of u by v. And that will be, the formula I have already told you. So it will be denominator square, that is x square whole square. Then you have x square and differentiation of e to the power x log x. So d by dx of e to the power x log x it will be. Then you can subtract e to the power x log x, you can bring it out. And you have to differentiate now d by dx of what? X square. So I'll deal with the denominator later. Let us see the numerator. So e to the power x log x will apply the product rule. What is the product rule? The first one, differentiation of second one plus differentiation of the first one and the second one. So e to the power x 1 by x, log x is 1 by x, log x e to the power x. So what do we get? X square, you can take this out, x by x plus e to the power x log x. And what do you get here? X square will be 2x. So you can just write 2x e to the power x log x. Now there are multiple ways to do it. Okay. That is, you have in the denominator x to the power 4. You can take certain thing common from the numerator because as you will see, x is there. So you can take x common, 1x common. Okay, 1x I have taken common from all the terms because x is in both the terms which we see here. And we have in the denominator x to the power 4. So 1x will be cancelled, 1 by x cube it will be. So 1 by x cube we got. This is what we have in the denominator, you can say. And let us multiply this now. E to the power x, I am multiplying it, okay. And e to the power x also I have taken common because you see e to the power x is also everywhere. So e to the power x you can cancel out, one of the x you can cancel out because they have already been taken out. And one of the x got cancelled with the x to the power 4 in the denominator. What is left? X into e to the power x by x into x into e to the power x log x minus here you get 2 e to the power x log x. Okay. Now e to the power x log x, e to the power x log x is there, but even if you take common it will be x minus 2. So there is no point in that. What you can do here is because e to the power x is already outside, you can just simplify a little bit. As I said, e to the power x is already taken common. This x's gets cancelled. So you have e to the power x already taken common. Sorry. So 1 plus x log x and minus 2 log x. Now you can leave it here. So this is also your answer. But if you want to match it with the answer in your book, so you have to multiply one of the x inside. What I am trying to suggest here is x cube is x square into x. You can take this x inside. You can keep it like this. I am just saying that e to the power x, x to the power minus 3, you can keep it like that. It will not be affected. But still, just to match the answer, x I am taking in the denominator, 1 by x will be there, 1 by x will be everywhere. So 1 by x minus, and this x gets cancelled. You have log x here, minus 2 log x by x. This can be your final answer. But it's up to you where you want to stop. Differentiate log cosec x minus cot x. So this question is very straightforward. If you have done up till now or understood very well what we have just discussed. So this is not very complicated. You can try, but still I'll take it. Those who want to just go forward, they can just have a look and go forward, right? So this log x, log of anything will be 1 by that of thing. So 1 by y, if you assume the cosec x minus cot x will be in the denominator. So 1 by cosec x minus cot x is simply log of something, that is 1 by of that something. Now d by dx of what is inside? Cosec x minus cot x. So what will be cosec x differentiation? Cosec x is minus cosec x cot x. This is the differentiation of cosec x. And what is cot x? Cot x will be minus cosec square x. So you can just write minus cosec square x minus will be plus. So you can take common also. You can change the position so that you get the negative in the middle. And you can take just cosec x common. So when you take cosec x common, it will be cosec x minus cot x in the inside. So you have cosec x minus cot x. So this is the numerator we are getting, cosec x into cosec x minus cot x. But if you remember, there is already cosec x minus cot x in the denominator. So this gets cancelled out. Only cosec x will remain. That is your final result, cosec x. Now differentiate this one. So there are multiple ways to do it. There is a straightforward way without even making it easier or simplified that you can do. That I'll tell you also how to do that. And this one thing you can do, e to the power 2x, this you can write as e to the power 2x in the denominator. Here you have e to the power 2x, subtraction of 1 by e to the power 2x. And this will become what? Numerator will be e2x will be e4x and plus 1 divided by e2x. All I am saying is the raised to the power, okay? E to the power 4x minus 1 by e2x, and this e2x gets cancelled. E to the power 4x plus 1 by e to the power 4x minus 1. Now this is very easy to deal with. This can be done quite easily, and this way also you can proceed. But the scenario here is because this is the basic exercise, first basic differentiation exercise. So we'll do the way it should be done. I mean, this is a u, this is a v. So we'll follow a proper rule, though it is somewhat lengthier, but we'll do it. So denominator will be the denominator square, and then this term e to the power 2x minus e to the power minus 2x, then d by dx of the first term. So d by dx of e to the power 2x plus e to the power minus 2x. Then you have a subtraction minus. So d by dx, and this you have to bring first. So e to the power 2x plus e to the power minus 2x. And then in the inside you have d by dx of a minus term, that is e2x minus e minus 2x. Right? So let us do it, because I would want you to do it by yourself, but because this is, as I said, initial exercise, as I just indicated earlier. So d by dx of e to the power 2x plus e to the power minus 2x, e raised theta is e raised theta only. So e raised 2x, 2x is 2, and e raised minus 2x will be e raised minus 2x, and minus 2x, differentiation will be minus 2. Minus 2 will also come. So this becomes 2 into e raised 2x minus e raised minus 2x. So let me write it here. E raised 2x minus e raised minus 2x. Once again, this 2 I have taken out, and same thing will come. E raised 2x minus e raised minus 2x. So this is square of that term. E raised 2x minus e raised minus 2x whole square. Here in the second part, e to 2x plus e minus 2x. Now when you have a negative here, so that becomes a positive. Same thing with analogy and similarity also you can just check. So e raised 2x will be e raised 2x, e raised minus 2x will be e raised minus 2x and minus 2. So you'll get a 2 here, minus 2 here. So minus minus will become plus. So this will be e raised 2x plus e raised minus 2x with a 2 outside. This is 2, this is e2x plus e to the power minus 2x. Okay. Denominator will remain same. We'll just deal with the denominator later. But as I said, this is square. e2x minus e minus 2x, this is square. And 2 you can just take common. So I'm taking common 2 so that we can deal with the inside ones. And minus this e2x plus e minus 2x whole square. e2x plus e minus 2x whole square. So you have a square minus b square. So you can just, either you can open it. See, there are two ways to do it. A minus b whole square you can open. A plus b whole square you open, and you can cancel it out. Or otherwise, see, ye have a squared minus b squared. So a plus b, a minus b you can do. That is, one time you can add, one time you can subtract. But I am opening just with a minus b whole square. So this is what I got. A square minus b square. A square plus b square minus 2ab. Here also a square plus b square plus 2ab. So e4x plus e minus 4x and plus 2 into e raised 2x, e raised minus 2x. Okay. So let us open this. It would have been easier if you have done a plus b, a minus b, as I earlier said. But this term e2x and e minus 2x. So 2x minus 2x power will be getting added. So 2x minus 2x is 0. So anything to the power 0 is 1. So this is going to be minus 2. So please remember, minus 2 will remain here. And there will be minus 2 also in the last. And what do we get when we open this? E raised minus 4x minus e raised minus 4x, same thing. So when you solve it, e4x and e4x will get cancelled. E minus 4x and e minus 4x will get cancelled. And 2 from the first term and 2 from negative 2 basically. Minus 2 from the first term and minus 2 from the second term. So minus 2 will become minus 4. And there is a 2 already outside. If you remember, the first step we did, we have taken 2 outside. Alright. So this minus 2 will be minus 4. This is minus 2. Because minus is already outside. So when you open it, it will be minus 2. So minus 2 will be minus 4. And you have a 2 here. So minus 4 into 2 is minus 8. And denominator we have e raised 2x minus e raised minus 2x whole square. This is going to be your final answer. Differentiate log of this content. So this is more of an algebra being applied here. So some of the part I'll leave it for you, but the steps I'll tell you what you have to do. Assume the numerator to be u, denominator to be v. So it will be, when you take log of something, it will be 1 by x, 1 by this whole content. This is 1 by u by v. So this v will go up and u will be in the denominator. So you will get x square minus x plus 1 divided by x square plus x plus 1. So this is your first step. V will go up, u will go. Why? Because this is just a reciprocal when you take log differentiation. Okay. X square plus x plus 1. Now this is done. This will remain like that. Now we have to differentiate this term. So I'll just tell you what we are going to apply. The algebra part I'm going to leave it for you. So we have the denominator square, x square minus x plus 1 whole square. Then we will put this x square minus x plus 1 and d by dx of x square plus x plus 1. So this is going to be 2x plus 1. 2x plus x plus 1 will come. Now minus. So we have x square plus x plus 1. So you can just write x square plus x plus 1. And differentiation of x square minus x plus 1. It is going to be 2x minus 1. So 2x minus 1. Alright. Now you have to multiply each term and multiply and then solve it. This is a simple algebra. You have done questions like this, I think, thousands of times. So you have to complete this. You have to multiply it with x square minus x plus 1 also. What I am trying to suggest here is not only this second part. Whole multiplication, there will be a lot of cancellation. And then finally multiplied by x square minus x plus 1. So the final answer I am writing. Minus 4x square plus 2x square plus 2. Algebraic part or normal computation, I am leaving it for you. So in the denominator, I will be writing x square plus x plus 1, which is remaining. And here x square minus x plus 1. Now can we have something of that sort which can be used in the denominator? Because numerator it is minus 4x square plus 2x square. So this 2x square minus 4x square is minus 2x square and then plus 2. You can just take minus 2 common, it will be x square minus 1. You will not get anything from the numerator, there is no cancellation. This will remain like that. The only thing is in the denominator, how can we make the denominator easier or in a simplified way we can represent it. So if I'll just try, because you have to write in the way so that it becomes easier, simplified. So I'll write a way and you'll see that will not work. For example, if I write x square plus 1 plus x plus 1, just say like that. And here I can write x square minus x. No, it is not getting. No, this is not becoming easier. So what we'll do here is we'll take some other way. I'll write this as x square plus 1 and then plus x. Here I can write it as x square plus 1 minus x. Now you see, this is the formula of a plus b and a minus b. A is x square plus 1, b is x. So a plus b, a minus b is going to be a square minus b square. So numerator will be minus 2x square minus 1, denominator will be a square minus b square. So you have x square plus 1 whole square minus x square. Now if you want to open, you can just open it. So x to the power 4 plus 1 plus 2 into x square. This is a plus b whole square minus x square. So x square plus 1 and this is 2x square minus x square is going to be x square. So this is in the denominator. So x square plus 1 is in the denominator. Minus 2x square minus 1 is there. So the calculation part I left it for you. If you have any trouble, you can just recheck it. Just having this solution in front of you. Differentiate tan inverse e to the power x. So here this is very simple solution, but the only thing is that tan inverse, sine inverse, cos inverse, what is the differentiation of these say trigonometric identities? So tan inverse is, if tan inverse x is differentiated, it is going to be 1 by 1 plus x square. 1 by 1 plus x square. So if this is e to the power x, it will be 1 by 1 plus, in place of x just put e to the power x, because it is square, so it will be e to the power 2x and then e to the power x again. So this is the final answer. So ex by 1 plus e 2x. Now differentiate e sine inverse 2x. Now e to the power theta or e to the power x, the differentiation will remain same. It will be e to the power theta only. Okay. First differentiation will be same, e to the power sine inverse 2x. Now this with the chain rule, d by dx of sine inverse 2x has to be done. What is d by dx of sine inverse 2x? See, this is sine inverse 2x. You know sine inverse theta or sine inverse x. If the differentiation is done, it is 1 by under root 1 minus x square or theta square, whichever you take. So here, this will remain same. But d by dx of sine inverse 2x will be 1 by under root 1 minus 2x whole square. And what is 2x whole square? It is 4x to the power 2. So this is e raised sine inverse 2x, and then we have 1 by under root 1 minus 4x square. But still 2x is remaining. So differentiation of 2x will be 2. Right? This is your answer. So differentiate sine. In the bracket we have 2 sine inverse x. 2 sine inverse x. So sine theta is simple cos theta. D by dx of sine theta is nothing but cos theta. So this will be cos 2 sine inverse x. This is cos. Now 2 sine inverse x, 2 will come outside. And what is the differentiation of sine inverse x? We have just seen. It is 1 by under root 1 minus x square. Okay. This is your final answer. This you see. You can just manage them to look clean, beautiful, smooth to the examiner. That is what you have to write. So this is all about sine inverse and tan inverse, cos inverse, like that. Now we are encountering tan inverse, and you know about that now. So e raised to the power tan inverse under root x. So first is e raised to the power something will be e raised to the power something. So it will be e raised to the power tan inverse under root x. This is, and we have tan inverse under root x. So tan inverse x differentiation is 1 by under root 1 plus x square. But since we have a root here, so under root x whole square is, under root x is simply x to the power half. If you multiply it by 2 or take the square, 2 gets cancelled. So this under root x, the differentiation of this is 1 by 2 under root x. Now combine them. This is your final answer. Under root tan inverse x by 2. So this tan inverse x by 2, you can write it as 1 by 2. But remember, anything root is, differentiation is 1 by 2 under root of that thing. That is, if you take under root x, you take the differentiation, it will be 1 by 2 under root x. Alright? So we have 1 by 2 under root tan inverse x by 2. Alright? Now tan inverse x by 2 you have to do. So tan inverse theta, I already told you, is simply 1 by 1 plus x square, or 1 by under root 1 by 1 plus theta square. Here this is x by 2. So it is 1 by 1 plus x plus 2 whole square. And then x by 2 differentiation, again it is going to be half. So the final answer will be what? This 1 by x plus 2 whole square becomes 1 plus x square by 4. So when you add this 1 by 1 plus x square by 4, it is going to be 1 by 4 plus x square, and this 4 goes up. And now we have this 4 plus x square in the denominator, that you can keep. And then we have this 2 and 2, and this gets cancelled with the 4. The final will be what? 1 by 4 plus x square and under root tan inverse x by 2. Okay. So this is your final answer. Now differentiate log of this thing. So log of tan inverse x, log of something is 1 by that thing. That is 1 by tan inverse x it will be. So 1 by tan inverse x it will be. Now tan inverse x is 1 by 1 plus x square. So 1 plus x square you can write. This will be your final answer. So there is no trick, there is nothing, just you need to know what are the differentiation of tan inverse, cos inverse, sin inverse. Now this is u and this is v. The numerator is u, denominator is v. Now u by v, when we differentiate this, the denominator will be this x square plus 3 whole square, and this square whole square. This is square. This is what is given. You have to take the square of square. So x square plus 3 to the power 4. Now x square plus 3 whole square d by dx of 2 to the power x cos x minus 2 to the power x cos x and d by dx of x square plus 3 whole square. Now let us take this 2 to the power x cos x, because this d by dx of 2 to the power x cos x, that is two terms they are, and this will be by the product rule. So this is 2 to the power x cos x is minus sin x, and then we have a cos x 2 to the power x will be 2 to the power x only. A to the power x is a to the power x log base EA. So this is a to the power x, we are doing 2 to the power x or 2 to the power x log base E, and then we have 2. Now let us do this one, x square plus 3 whole square. So x square plus 3 whole square, it is going to be twice of x square plus 3, and then x square plus 3 will be done again, it will be just 2x. So I am making it 4 and I am writing it as x, because 2x will come. Now this is the verification part. You can just see if you are doing by yourself, then this is the thing. But we will continue our doing what we were doing. So what we will do here is, we'll just put these values which we just found. So it is x square plus 3 whole square, and then we have this in place of 2 raise x cos x, I am writing 2 raise cos x, and then log 2. I am just exchanging the places so that the negative comes in between. Then we have 2 to the power x sin x, then minus 2 raise x cos x, and this is 4x and x square plus 3. Alright. So now in the denominator you have x square plus 3 to the power 4. So I am now taking x square plus 3 whole square from two terms which are above. So if we take x square plus 3 whole square, and since there is only one x square plus 3 here, so if I take x square plus 3 whole square common, I have to divide it by x square plus 3, because the first term has x square plus 3 whole square, the second term has only one x square plus 3, so we have to divide it by x square plus 3. So x square plus 3 whole to the power 4, 2 gets cancelled, so 1 by x square plus 3 whole square it will be. This is 2 to the power x, 2 to the power x. This also you can take out. It is with every term. So what else is remaining? So this goes. So what else is remaining here? Whatever is remaining I am writing now. So it will be cos x log 2. Please remember the base is 2. Then we have minus sin x here. Then this is going to be 4x cos x divided by x square plus 3. Okay, this is your final answer. Alright, this is your final result. So here we have 4 terms. So we'll just separate them and differentiate them separately, and then we are going to add them. So d by dx of x sine 2x. So it is going to be the first term. We'll apply the product rule here. So x sine 2x is cos 2x, then 2x is 2. Then we have, see, sine 2x is cos 2x and 2x is 2, plus sine 2x d by dx of x is 1. So we have 2x cos 2x plus sine 2x. This is the d by dx of x sine 2x. What is the d by dx or differentiation of 5 to the power x? It is going to be a to the power x log EA. So 5 to the power x log base E5. K to the power k is what? Because it is a constant. So d by dx of k to the power k is going to be 0. I am not writing it, but it will be 0. So it won't affect. And d by dx of tan square x to the power q. So it will be 3 tan square x to the power square, because it is to the power 3. Then we will do the tan square x. Tan square x will be what? 2 tan x. Then we will do the tan x. It will be sec square x. So what all we get? This is 3 to the 6 and 10 2 to the 4. 10 to the power 4. Here we have one more tan. So 10 to the power 5 x and sec square x. So you need to verify, or if you are doing it by yourself, you can just validate. So it will be 2x cos 2x plus sin 2x and then this was 0, so we have 5x log 5 log base e 5 plus 6 10 5x and sec square x. This is your final result. So same thing we are going to do here. There are two terms here, so we'll handle them separately. So log 3x plus 2 d by dx, log of anything it will be 1 by of that anything. So 1 by 3x plus 2, and the differentiation of 3x plus 2 is going to be 3. So this is 2 will be 0 and 3 will come out, d by dx of x is 1. So you have a 3 here. And then we have d by dx of x square log 2x minus 1. So there are two terms here, x square and log 2x minus 1. So x square log x will be 1 by 2x minus 1. And then the differentiation of 2x minus 1, only 2 will remain. So let me write it 2 here. And then plus log 2x minus 1. Differentiation of x square is 2x. Alright. Now we just have to subtract these two terms, and we can just take some, if you have something in common. So I'm just writing these two terms with a subtraction because I have taken the d by dx of them separately. So this is the final term which has come. Now, if you want to make it more easier, it's up to you. Otherwise, you can just leave it like that because that is the final answer. Now 3x square sin x by under root 7 minus x square. So this we will use the u by v, that is the quotient rule. In the denominator, we have under root 7 minus x square whole square. So it will be 7 minus x square x square only, because this root, that is the power of half, is going to get cancelled. Then you have root 7 minus x square here, and d by dx of 3x square sin x will do 3x square sin x minus under root 7 minus x square. This differentiation will be done. So 3x square sin x I'll take outside, and d by dx of under root 7 minus x square. If you're doing it by yourself, just have a look at the left hand side and you can just go ahead. But we are doing it, so we will be doing it by d by dx of 3x square sin x. So this 3 will come out. I will use it later. X square sin x. So x square sin x will be cos x plus sin x will remain like that, and x square will be 2x. Now you can just multiply it by 3, or you can just keep 3 outside and you can write x square cos x plus 2x sin x. Okay. So we will replace it here. And this term, see, under root 7 minus x square, I am writing it as 7 minus x square to the power half. And this I am going to write 3 outside, and x square cos x plus 2x sin x. This. And then minus 3x square sin x, and d by dx of something is what? Of root. So under root x is 1 by 2 under root x. So 1 by twice of under root 7 minus x square. 1 by 2 under root 7 minus x square it will be. So this is 7 minus x square to the power half. 7 minus x square root is 7 minus x square, but differentiation of 7 minus x square is 1 by 2 under root 7 minus x square. Then differentiation of 7 minus x square will be minus 2x. So minus minus become plus. And then we have the 7 minus x square in the denominator. So we have a 7 minus x square in the denominator. So I'll just take this for these two numerators separately. 7 minus x square here. Now you see the power of 7 minus x square is half in the numerator. When it comes down, it will be going to be 7 minus x square to the power minus half. That is a to the power half. Denominator is a. If this a to the power half comes downstairs, a to the power 1 minus a to the power minus 1 by 2, the power gets added. So it will be a to the power half. Okay. So this is going to be, even if you want to multiply, see 3x square cos x plus 6x sin x has come like that. So I'm just writing it like that. You can just multiply it inside if you want. But we are dealing with 7 minus x square to the power half. So it will be under root 7 minus x square. This is going to be like this. Plus, now this is going to be 2 gets cancelled. 2 is 6. So I'll write just 3 here. So this is going to be 3. And this 7 minus x square to the power 1 and 7 minus x square to the power half. So 1 and half gets added. It's going to be 3 by 2. So 7 minus x square to the power 3 by 2. Okay. So this is your final answer. Okay, you can match it also if you are doing it by yourself. Differentiate sine square log 2x plus 3. So the coming questions are very straightforward, which we will be doing today. And those who wants to just skip, they can just see the solution, and if they are comfortable, they can go ahead. So this sine square is equivalent to x square. So the differentiation is 2x simply. So when you do the d by dx of anything square, the 2 will come in front and sine 2 minus 1, that is sine of log 2x plus 3. Alright. Now this is the first thing. Now then we have to differentiate the sine of log 2x plus 3. That will be simply cos of some whichever you have theta inside. So cos of log 2x plus 3 it will be. Okay. Now this is the chain rule we are adopting. Then log 2x plus 3, what is the differentiation of log? So I am writing there is a continuity, but I am writing it in the second line. So it is going to be 1 by 2x plus 3. Please remember, log theta or log x is 1 by x. Now differentiation of 2x plus 3, that is 2, d by dx of x is 1, d by dx of 3 is 0. So you have a 2 here. Okay. So 2 sine cos, the theta is same, and this is 2 by 2x plus 3. These are all in continuation. But you see here, we know that 2 sine theta cos theta is sine 2 theta. This is 2 sine theta cos theta, and you can directly write it as sine 2 theta. So this is sine 2, and what is the theta? It is log 2x plus 3, which I have written here also. So let me write it just for completion. Sine and the twice of log, and then what is inside 2x plus 3. So sine 2 log 2x plus 3, and then we have 2 by 2x plus 3 in the denominator. Differentiate e raised x log sine 2x. So there are two terms here in multiplication, e raised to the power x and log sine 2x. So this is also a very straightforward answer of this question, and you can just have a look, and if you want to just go ahead, go ahead. And those who want to understand, this is d by dx of two terms, and when you have two terms in multiplication, we adopt the product rule. So e to the power x d by dx of log sine 2x, and log sine 2x will be here, and d by dx of e to the power x. Okay, d by dx of e to the power x. Now this term, see, e to the power x will be e to the power x. So I am writing the second term first. E to the power x and log sine 2x will be log sine 2x. Then this is e to the power x and d by dx of log sine 2x. Now log sine 2x will apply the chain rule here. Log theta is 1 by theta. So you have 1 by sine 2x, and then sine 2x is cos 2x, and then 2x again. Differentiation of 2x is 2. So this is 2 cos x by sine x, or cos theta by sine theta will be cot theta. So you can just write it as 2 cot 2x. So here it will be 2 cot 2x. This was the first term, and this is the second term. Okay. Now this is differentiation of a term which has a root but the similar term, almost similar term inside. The solution of these say expression is using the rationalization. So I am calling x square plus 1 as a, x square minus 1 as b. So I am writing it in terms of a and b just to write less and understand more. So under root a, then we have plus under root b. Same thing I am writing, but I am rationalizing it. So I am multiplying the same thing with plus sign in the numerator and denominator, so that we get in the denominator without root values. So numerator will be root a plus root b whole square. Denominator will be this term a minus b, a plus b. So it will be a square minus b square. So we have x square minus y square if we have x minus y into x plus y. So this will be x square plus 1, that is root will be eliminated, minus x square minus 1. What do you get? X square plus 1 minus x square plus 1. So x square gets cancelled, you get 2. So this is 2, we are going to use it later, or we'll write it later. So 1 by 2 is already there, it is in the denominator. I just told you about the denominator. And now coming to the numerator, it is simply under root a plus under root b whole square. So under root a whole square will be only a, under root b square will be only b, plus 2 into under root a into under root b, which will be eventually 2 into under root ab, twice of under root ab. So this is a, which is actually x square plus 1. B we assume to be x square minus 1. And here we have 2 twice of under root. Now just multiply x square plus 1 and x square minus 1. This is equivalent to x square plus 1 square and x square minus 1 square. This is a minus b, a plus b again. So a square minus b square it will be. So x square to the power whole square minus 1 square. You get x to the power 4 minus 1. Now here 1 gets cancelled. You will get a 2x square, and you also have a twice of under root x to the power 4 minus 1. So this 2 you can just take these out and you can cancel it with the denominator we already told you in the beginning. So only x square plus under root x to the power 4 minus 1 will remain. So ultimately we have solved this, and now we have to differentiate this. So d by dx of x square is 2x, d by dx of anything with the root is 1 by twice of under root that term, which is x to the power 4 minus 1. Now x to the power 4 minus 1, differentiation of this will be 4x cube. So let me write 4x cube here. So it will be 2 to the 4, so 2x plus twice of x cube and divided by x to the power 4 minus 1. This is the whole differentiation. So we have this log term. So you can say that there are two terms inside log, one term normal, one term with the under root. So log of something will be 1 by that of that thing. So we have 1 by x plus 2 plus under root x square plus 4x plus 1. Now differentiation of x plus 2 will be what? It will be 1, because 2 will be 0, d by dx of x will be 1. Alright. So you have 1 here. This is 1. Then plus differentiation of this root term will be 1 by twice of under root. This is twice of under root x square plus 4x plus 1. Then we have to differentiate the x square plus 4x plus 1. X square will be 2x, 4x will be 4 and 1 will be 0. So you have 2x plus 4 here. So you can take 2 common. It will be twice of x plus 2. 2 gets cancelled. You just get x plus 2 in the numerator. Alright. Now we have to solve the term which is inside this square bracket. So it will be 1 into this under root term. So it will be and 1 into x plus 2. So let me write x plus 2 first. X plus 2 plus x square plus 4x plus 1. And the denominator you have under root x square plus 4x plus 1. Now this is 1 by this term, which is x plus 2 plus under root x square plus 4x plus 1. Now you see this term and this term gets cancelled. Only 1 by under root x square plus 4x plus 1 will remain. That is your final answer. So the round I am making is the final answer. Differentiate the sine inverse x to the power 4 to the power 4. So if you had take it as y to the power 4, the differentiation of this will be 4y cube. So 4 into y, this sine inverse x to the power 4 to the power cube. So this is the first step. Then you have to use the chain rule. Now you have to differentiate the sine inverse x to the power 4. Sine inverse is what? 1 by under root 1 minus x square. Sine inverse theta differentiation is 1 by under root 1 minus theta square. So 1 by under root 1 minus this is theta square. X to the power 4 to the power square. So it will be 4 into 2, that is x to the power 8 it will be. Now x to the power 4. Differentiation of this, because we are using the chain rule. So it has to be applied. 4x cube it will be. So what is the final answer? 4 4s are 16. X cube, then sine inverse x to the power 4 to the power 3. And in the denominator you have under root 1 minus x to the power 8. So you have under root 1 minus x to the power 8. This is your final answer. This is sine inverse of whatever content is inside. If you want to just have a look at the solution, I'll just give you. But if you want to learn, then sine inverse of something differentiation is 1 by under root of 1 minus that thing square. So it will be 1 by under root 1 minus x square by under root x square plus a square whole square. So it will be x square plus a square only. Now this x denominator, I am doing the denominator now, which is inside under root. So x square plus a square minus x square divided by x square plus a square. X square get cancelled, you get a square by x square plus a square. Now when you take the root, and this root is going to go, this a by under root x square plus a square will go up, because it is a reciprocal, 1 by something. So under root x square plus a square goes up, a in the denominator. Now let us do this one also. Now because we are doing the chain rule. X by under root x square plus a square. So this is u, this is v. And when we call one as u, one as v, that means we have to apply u by v, the quotient rule. Quotient rule is the square of the denominator, which is x square plus a square. Then we have under root x square plus a square here. And then differentiation of a square plus x square here. X square plus a square also you can write. D by dx of x is 1 only. So I am just leaving it into 1 is the same thing. Minus x into d by dx of x square plus a square. So 1 by twice of under root x square plus a square, and the differentiation of x square plus a square is going to be twice of x. X square plus a square will be 0, x square will be 2x. Now 2 gets cancelled, x will become x square. I am doing the numerator right now. So this is going to be under root x square minus a square, x square plus a square, sorry. X square plus a square minus x square divided by under root x square plus a square. Now this is numerator. So let us take the LCM and solve it. So under root x square plus a square, under root will get vanished. Minus x square divided by under root x square plus a square. And this x square plus a square, and you have a x square plus a square in the denominator also. So x square you can cancel. This is a square by x square plus a square in the under root, and there is already an x square plus a square there. So this is, we can just cancel this out. The power is half and power is 1. We don't have to worry about that because there is one term already there. Okay. So we have to multiply here a square by under root x square plus a square, and this is x square plus a square. Now you just cancel these two out, a with a. So it will be simply a by under root, a by x square plus a square. There will be no under root because under root we have already cancelled. This is going to be your final answer. These are the steps, these are the things you have to write. So I just wanted to save time, so I don't write all these. I just show it to you. Differentiate e to the power x sin x by, and this is cube, x square plus 2 whole cube. So again quotient rule, u is the numerator, v is the denominator, and we'll apply the quotient rule. Quotient rule is saying that we'll apply the product rule in e to the power x sin x, but let us see here. In the denominator we have x square plus 2 whole cube to the power 2. So whole cube to the power 2 is going to be 6. This is raised to the power 6. And this is x square plus 2 whole cube. And then d by dx of e to the power x sin x, we'll do it just now. We'll apply the product rule. And minus e to the power x sin x will come outside. And d by dx of x square plus 2 whole cube. So d by dx of x square plus 2 whole cube. let us see this one by one. I am differentiating the e to the power x sin x. E to the power x sin x will be cos x plus sin x will be like that only, and e to the power x will be e to the power x. So e to the power x I wrote, then differentiated sin x, then sin x, then it differentiated e to the power x. This is the first one. The second one will be, I am differentiating this now. So 3 will come in front, 3 x square plus 2 whole square, because 3 minus 1 is 2. And then differentiation of x square will be 2x. Final will be 6x x square plus 2 whole square. Okay. So if you want to just do it by yourself, you can just have a look here, and what you have to write, you see there. Now let us continue. X square plus 2 whole cube, and then e to the power x sin x, the differentiation I am copying it here, writing it here. It is e to the power x cos x plus e to the power x sin x. And then we have a subtraction, and 6x x square plus 2 whole square it will be, along with e to the power x sin x. So let us arrange them the way the examiner wants us to do. So we have 6x e to the power x sin x and x square plus 2 whole square. Alright. Now the thing, all steps are done. In the denominator you have x square plus 2 whole to the power 6. Okay, this is x square plus 2. Okay. Now you have x square plus 2 whole square here. So you can just take x square plus 2 whole square common. So x square plus 2 whole square, when you take common, this will be 1 remaining. This will all be gone. So x square plus 2 whole square, when we have taken out, you have x square plus 2 in the denominator with the power 6. So 2 and 6, this 2 comes in the denominator, 6 minus 2 is 4. So x square plus 6 to the power 4 it will be. Now you can take them separately. So you have, this is x square plus 1, x square plus 2, so e to the power x cos x plus ex sin x. One value will be deducted. So it will be x square plus 2 whole cube minus, this is 6x e to the power x sin x, and divided by x square plus 2 to the power 4. Okay. So this is the final result of this, but the way you need to write, it's up to you. And because the examiner want us to do this x square plus 2 separately, we have done that. Now 3 e to the power minus 3x log 1 plus x. So there are two terms here. Constant we don't count because we don't differentiate it. And e to the power minus 3x log 1 plus x. Again, it is a very straightforward question. If you just want to do it, you can just have a look and go forward. But who just want to see, they can see what I am doing. E to the power minus 3x d by dx of log 1 plus x, I am applying the product rule, and then plus log 1 plus x and differentiation of d by dx of e to the power minus 3x. E to the power minus 3x log theta will be 1 by theta, so 1 plus x will be in the denominator. 1 plus x, the differentiation will be only 1. And then we have, I know that e to the power minus will give you minus, so I'm not writing the sign right now. E to the power minus 3x will be e to the power minus 3x, and minus 3x will be giving you minus 3, and log 1 plus x. So you have minus 3 e to the power x log 1 plus x. What you can do here is you can just take this e to the power minus 3x common, that is, and there is a 3 which was outside. Remember, the question has 3 into something, so you can keep 3 here, and you can just take this e to the power minus 3x outside because it is common to both of it. Alright, so whatever is remaining is your answer. Differentiate x square plus 2 divided by under root cos x. Now assume the first one, the numerator to be u and denominator to be v. So this kind of question we have already done. So if you just want to skip or you want to do it by yourself, I have presented the answer also. But those who want to learn how this is being done, you have to use the quotient rule. And quotient rule is which we have done already a lot of questions using this quotient rule. So this under root cos x whole square will be cos x only. Then this under root cos x will come here. Then a differentiation of d by dx of x square plus 2. X square plus 2. Then we have a subtraction. And this x square plus 2 will come in front. And then we have d by dx of under root cos x. The differentiation of x square plus 2 is going to be 2x. Differentiation of under root cos x will be 1 by 2 under root cos x. And this cos x, because we are applying the chain rule, cos x will be minus sin x. Now let us replace this here. What do we get? We get 2x into under root cos x. And then we have subtraction x square plus 2, and minus minus will become plus, and this is going to be sin x divided by twice of under root cos x. Twice of under root cos x. Okay. Now we can simplify it. This is what we have done. There is no differentiation left. There is just simplification. So let us take the LCM. 2x, so 2 to 4x, under root goes. So 4x cos x. This is going to be x square plus 2 sin x, and then in the denominator we have twice of under root cos x. The twice under root cos x will be in the denominator. So we can combine them because cos x was already there in the denominator, remember? So under root cos x to the power half and cos x to the power 1, that is going to be cos x to the power 3 by 2. Well, we will be changing it. But as of now, it is cos x to the power 3 by 2. So now let us separate them because there is a plus sign. So let us separate with the same denominator so that we can simplify them. And that is going to be, if something is common, then also we'll take something common. So when you take this 4x into cos x divided by twice of cos x to the power 3 by 2. This will be your first term. Then second term will be x square plus 2 sin x and divided by twice of cos x to the power 3 by 2. Okay. Now this cos x, you can bring it in the denominator. So cos x to the power 1 will become cos x to the power minus 1. So 3 by 2 minus 1 will be, as we just did, half plus 1 is equal to 3 by 2. So this can be written as 3 by 2 minus 1. So it is going to be half. This is going to be 100 root cos x only. And this we have finally 2x by under root cos x. So here we are getting nothing like that. But what we can do with the cos x is, again we can write this cos x as same as like under root cos x and cos x. So under root cos x minus cos x is going to be cos x to the power 3 by 2. Alright. Now sin x by cos x becomes 10x. And under root cos x is in the denominator. You can take it outside, 1 by under root cos x. This is 2x plus, this is going to be x square plus 2. And then we have a tan x here. And then we have twice of, because under root cos x we have already taken out. This is the final answer. Differentiate this term. Now I'll show you the solution that you will be tempted to do, you should do. But I will give you a different solution because the answer may vary in terms of viewing perception, but they are ultimately same. What does it mean? See, we have to multiply this x square with 1 minus x square, because if you are going to do it like that, you have to apply the product rule. So we have so much complication here, so we will try to minimize the computation. Better is to multiply this x square with 1 minus x square. So when you multiply x square with 1 minus x square, it will be x square minus x to the power 4. So this is u, this is v, u in the numerator, v in the denominator. In the denominator you get x this cos 2x to the power square, that is in the denominator. We have cos 2x here, d by dx of this whole, x square minus x to the power 4 minus this term goes here, x square minus x to the power 4. Then the differentiation of cos 2x will be minus sine 2x. I'll just show you the differentiation of both of them. First, let us differentiate the x square minus x to the power 4. It is going to be 2x minus 4x cube. You can take 2x common from here if you want, just to make them simple. So it will be 1 minus 2x square inside. 1 minus 2x square. Okay. This is the differentiation of x square minus x to the power 4. So 2x into 1 minus 2x square. And then we have a cos 2x already here, cos 2x. Then minus, this is x square minus x to the power 4. X square minus x to the power 4. And differentiation of cos 2x we have to do. I'm just rechecking it because you will be finding some difference in the answer. But the process and the procedure remains the same. The d by dx of cos 2x is minus sine 2x. So 2x will be 2 because product this question rule followed by the chain rule. So we have plus 2 sine 2x and x to the power square minus x to the power 4. In the denominator we already have cos 2x whole square, that is cos square 2x. So let us write it in the denominator of both these terms. This is cos 2x whole square. This is also cos 2x whole square. Alright. This is whole square. So this cos 2x, 1 gets cancelled in the first term. So this you can write it as 2x into 1 minus 2x square. Cos 2x you can bring in it up in the numerator. It will be sec 2x. So this is twice. And this is going to be, now sine 2x and 1 cos 2x can be combined because cos 2x whole square is cos 2x into cos 2x. So 1 sine 2x with cos 2x will be called the tan 2x. And this is going to be x square minus x to the power 4. You can just directly write it, or you can take something common from here. You can take x common. I'll take all of it common. That is 2 sine 2x cos 2x. One of these will I've written already. 1 cos 2x will remain. This cos 2x, when it goes up, it will be sec 2x. This is the inversion of cos 2x. It will be sec 2x. Now what is remaining when you take x outside from x square minus x to the power 4? It is going to be x minus x cube. Now sec 2x, let us take common. Sec 2x from here. This is 2 also you can take common. So 1 minus 2x square, it will be inside. This is the first term. Since we have taken 2 from here, x from here, and tan 2x will remain, x minus x cube. So you can write it as x into 1 minus x square. That also you can write. This is your final answer. Okay. Now what I am trying to suggest here is, if you see the answer which is there in the RD SHARMA, and this way which I have done, there is no difference. I just made a step easier. Otherwise the first numerator has to be, whenever you have a d by dx, you have to apply the product rule for x square and 1 minus x square. I just liberated you from that extra step. Next is log cot pi by 4 plus x by 2. So this is cot theta basically. So log of anything will be 1 by that thing, 1 by that thing, that is. So 1 by whatever is there inside log. It is going to be cot. This is pi by 4 plus x by 2. This is 1 by cot of this. And then we will be applying what? The cot of, because this we have to apply the chain rule. So cot of this, differentiation of cot of this term is going to be, because cot theta differentiation is minus cosec square theta. So whole of this with minus cosec square. So you have minus cosec square, and then you have inside pi by 4 plus x by 2. Now you have to differentiate pi by 4 plus x by 2 also. We have to go until no differentiation is left. So the differentiation is 1 by 2. Okay, this is your final. But let us try to minimize and simplify it. We don't keep it like that. So we have minus half. So let us write this minus half. Okay, cosec square pi by 4. Let us assume it to be some theta. So 1 by cosec square is this cosec square is 1 by sine square, and cot is cos by sine. So this is cos, this is sine. Now you can cancel this 1 of the sine, and since there is already a twice here, so 2 sine theta cos theta or 2 cos theta sine theta is sine 2 theta. In the denominator you have sine 2 theta. So what we have is minus 1 in the numerator, and this sine twice of pi by 4 plus x by 2. So when you multiply 2 with pi by 4 plus x by 2, it is going to be what? See, I am going to multiply, this is pi by 2 plus x. I have already multiplied 2. So sine 90 plus theta is cos theta. You can just write it as cos theta, because in second quadrant the sine is positive. So you have minus sec theta, cos goes up. Differentiate e raise ax sec x tan 2x. Now you will learn in this question how to differentiate when you have in multiplication more than 2 terms. When you have 2 terms, you just directly apply the product rule. But here we have more than 2 terms. We have actually 3 terms. So it can be 3, 4, 5, n number of terms. So the way we actually do or solve this kind of question, any of one we take one, and the other 2 we take them again as one term. So e raise ax d by dx of sec x tan 2x, then sec x tan 2x and d by dx of e raise ax. Alright. So this I will do the differentiation of sec x tan 2x. We will be applying the product rule again. So sec x d by dx of tan 2x plus tan 2x d by dx of sec x. Okay, so this is going to be sec x. Tan 2x will be, you know that tan, what is the differentiation of tan theta? It is sec square theta. So just write it as sec square tan x. And differentiation of sec x is sec x tan x. So tan x is sec square, this is sec x, sec square 2x, and differentiation of 2x is going to be 2 only. Alright. Then you have tan 2x, differentiation of sec x is sec x tan x. So this is just the differentiation of sec x tan x. Now we have to multiply this whole with e raise ax. Alright. And then we have another term also, which is plus sec x tan x d by dx of e to the power ax. So let us write it here. I am just now putting the differentiation of sec x tan x along with all the other term. And what is the differentiation of e to the power x? It is e to the power x, and differentiation of ax will give you a. So a e to the power x. So essentially you will get a e to the power x sec x tan x. E to the power ax, and you have twice sec x sec square 2x plus tan 2x 2x and sec x tan x. Then we have plus a e to the power ax sec x tan x. Sec x tan x. Now what you can do here is you can take certain thing common. E to the power x from here, and then you can take sec x, sec x, sec x from here. So what will you get? E to the power x, sec x we have taken common. Whatever is remaining, just write it here. So I am just cancelling those things so that there is no confusion. What all is remaining, let me write it here. It will be twice of sec square x, this first one I am just cancelling it, plus tan x tan 2x. This is going to be your second term, and then you have a tan x, tan 2x, this is third term. So again, let me tell you that this question is all about when we have multiple terms in multiplication and you have to apply the product rule on it. Differentiate log cos x square. What is log theta or log y? 1 by y. So we have 1 by cos x square. Now you have to differentiate cos x square. Cos x square you have to do. Cos is minus sine. It is going to be minus sine x square. Then we have to do the x square. 2x. X square differentiation is 2x. So sine x square by cos x square is tan x square. This is tan theta only. Sine by cos is. So you have 2x tan x square. And this is quite very straightforward kind of question. So this is how you are going to write in your exam or your classwork. Same thing with just a small twist. There is no special thing here. Just cos theta is sine theta. The differentiation of cos theta is sine of log x whole square. Sine is cos, cos is minus sine. Remember. So sine log x whole square. Then we have to differentiate the log x whole square. It will be twice of log x. Twice of log x. And because y square is simply 2y, differentiation of this is. And then log x is what? 1 by x. Okay? Right? Please remember cos is minus sign. So I am just putting the minus sign. So final will be minus, this is 2 log x. Then we have sine log x whole square. So this just write sine log x whole square. In the denominator you have x. This is your final answer. Differentiate log of this under root x minus 1 by x plus 1. So this kind of question we have already done. So if you just want to skip, you can skip. But I'll just, as a sake of completion, log of anything will be 1 by that thing. So when this 1 by under root x minus 1, under root x plus 1 will go, this under root x plus 1 will ultimately go to the numerator. What I am trying to suggest here is log of anything will be 1 by that thing. So this under root x plus 1 and under root x minus 1 will come finally, because under root x plus 1 will be going in the numerator. Now differentiation of under root x minus 1 and under root x plus 1. So this is going to be anything in the root will be 1 by twice of that thing. 1 by twice of under root of that thing. So you have this now d by dx of x minus 1 by x plus 1. So let us see what do we get here of the first two terms. Again under root x plus 1 is going to go up. So we have under root x plus 1 in the numerator, again under root x plus 1 in the numerator. It's under root x minus 1 in the denominator, under root x minus 1 in the denominator, 1 by 2. Under root x plus 1 whole square, that is x plus 1 only. Under root x minus 1 whole square, it is going to be x minus 1 only, 1 by 2 will remain. And this one. So what do we get? This is, we will use the quotient rule here. So x plus 1 whole square will be in the denominator. Then we have x plus 1 here. Differentiation of x minus 1 will be only 1. I hope you have a fair idea now. And minus x minus 1, differentiation of x plus 1 will give you again a value called 1. Okay, so you get x plus 1 minus x plus 1, x gets cancelled, you get 2 divided by x plus 1 whole square. Now 2 this gets cancelled, x plus 1 gets cancelled. You have in the denominator 1 by x plus 1 into 1 by x minus 1. A plus b, a minus b formula, that is a square minus b square. So you will get 1 by x square minus 1. So this is how you have to write. This is the way you have to actually write in your examination. I told you how to do this. On the right you see how to do this. Left you see how to write. Now if y is this term, then we have to show that dy by dx is this term. Basically we have to find out the differentiation only. But these type of questions, you'll see that the answer they want, the examiner want, there will be some kind of trick we have to apply somewhere. Okay, if you want to just go through the solution and do it by yourself, you can do it. And if you want to understand how to do this, let us start. Why is log of this term? So this, please remember, dy by dx is only the differentiation only, f dash x or dy by dx. These are the same thing. So we have y is equal to log of this under root x minus 1 minus under root x plus 1. Alright. So when you take the dy by dx, that is the differentiation. So log of anything will be 1 by that of that thing. So 1 by under root, this is going to be, just assume it to be a and b, just to save time. Under root a minus under root b. So the differentiation of the internal, that is the chain rule we are going to apply. So d by dx of anything of the root. So d by dx of anything with root is 1 by twice of that thing. Okay. So root of anything, d by dx of x, for example, it is going to be 1 by twice of under root x. This is the common thing which we have learned. Same thing we are going to do here. D by dx of this is 1 by twice of under root x minus 1. Okay. Now x minus 1 differentiation is x is 1 and 1 is 0. So there will be nothing. And 1 only basically. So this d by dx of under root x plus 1 is 1 by twice of under root x plus 1. And differentiation of x plus 1 is what? X is 0, 1 is x is 1 and 1 is 0. So 1 you will get. So this a I assume to be x minus 1 and this is to be x plus 1. So 1 by 2 I am taking common. We'll deal with it later. So 1 by 2 I am taking outside. What do you get? Under root x plus 1 minus under root x minus 1 divided by under root x minus 1 into under root x plus 1. So when you multiply this under root, x minus 1 into x plus 1 is x square minus 1 square. So under root ab it will be. So you have under root a into under root b. So under root ab under root x square minus 1 it will be. So denominator will be under root x square minus 1 and that will come in your answer also, which you will see here. So let me just write it here, under root x square minus 1. And then we have this 1 by under root. This is under root a minus under root b. What is a? X minus 1. So this is under root a. This is under root b minus under root a. So if I take a negative common from here, then it will be under root a minus under root b. That is under root. Same thing means under root x minus 1 x plus, minus under root x plus 1. So you can just cancel it out. Negative I took outside. There was already a 2 in the denominator and I told you under root x square minus 1 was already there. This is your final answer. Same thing here. Just we'll take certain thing on the left and the right to get to this answer. So for reference, same type of question only with a plus sign. What we are doing here. This is same thing, almost same thing. It doesn't have a log, but this kind of scenario will only come when we have some values we'll take on the left, some value on the right, like that. And essentially you don't have to worry about anything. You just have to differentiate it. So we will differentiate it. Dy by dx will be what? Alright. So let me do it. If you are confident that you will be able to do by yourself, just have a look at the answer and try it yourself. Now dy by dx of under root x plus 1 is 1 by twice of under root x plus 1. d by dx of under root x minus 1 is 1 by twice of under root x minus 1. What is the differentiation of x plus 1? 1. What is the differentiation of x minus 1? It is 1. So this, because of the chain rule, we have to do x plus 1 and x minus 1 also. But it is going to be 1 only. I am taking half common now. So under root x minus 1, I am taking LCM inside. And this is going to be plus under root x plus 1. In the denominator, we will get under root x plus 1 into under root x minus 1. And that is going to be under root x square minus 1 square, which I already told you. So this all is going to be, because this is you can take 1 by 1. See, this is y only. Under root x plus 1 and under root x minus 1 was what? It was y. So I am keeping it as y. Y by 2 under root x square minus 1. It is dy by dx. Now you can take this under root x square minus 1 on the left hand side. So under root x square minus 1 dy by dx is equal to y by 2 or half into y. Okay. Same thing here, but we will try to keep this y, which is x by x plus 2 somewhere. You'll see just now. And if you are able to understand the solution, it's given already. But we will have certain logic and trick here. So we have dy by dx and u by v, that is, we will apply the quotient rule. So d by dx of x by x plus 2 is going to be, in the denominator you have x plus 2 whole square, then we have x plus 2, then d by dx of x is going to be 1. So I am not writing it, minus, then we have x outside, d by dx of x plus 2 is going to be 1 only. So d by dx of x plus 2 is going to be 1. So x plus 2 minus x. Now we will be tempted to cancel these two, x and x, and it will be twice by x plus 2 whole square. This is dy by dx that we will get. But the answer is not like that. If you see, the answer is not like that. So we cannot do this. We will not jump into just simplifying it. We rather have to see what solution do we need. The solution we need is what you see in the proving. That is, prove that this one. So you need a y, 1 minus y. So we will keep this, we will not cancel these two. So x plus 2 minus x. So x plus 2 by x plus 2 whole square minus x by x plus 2 whole square. We will keep it like that. We will not cancel this x and x. Now you see x by x plus 2 is what? X by x plus 2 is y. So what you can do here is, you can keep this x plus 2 as x by y. X plus 2 will be x by y. So you can keep it like this, x plus 2 is x by y. And now we will replace wherever x plus 2 is there, x with x by y. So this x plus 2 whole square, you can just cancel these 1x plus 2. You will get 1x plus 2 in the denominator, so 1 by x plus 2. And in place of x plus 2, just replace it by x by y. So 1 by x by y, so y will go up, denominator will be x. Here again same thing, x by x plus 2 whole square. What is x plus 2? Which is x by y. So it will be x square by y square. This goes up. So this is y by x minus x gets cancelled. Y by x minus y square by x. Now you have the denominator as same. So you can just have one denominator, y minus y square by x. You can take y common, y minus y into 1 minus y divided by x. And this is dy by dx. This x you can take on the left hand side. So x into dy by dx is going to be y into 1 minus y. This is your final answer. Please remember that if we would have cancelled x plus 2 minus x and x, we wouldn't have achieved this answer. This has to be only done in a way I taught you. Now this is y equals log into root x plus 1 by root x. Dy by dx has to be given like this. We have to prove like this. So the solution is in front of you. If you just want to carry on, you can just go ahead for the next question. But those who want to actually get how it is going to be solved, so just assume this under root x plus 1 by under root x is a. So log of anything will be 1 by that thing. So I am assuming that to be a. And this is a root x differentiation is 1 by 2 root x. 1 by under root 2x. So what it will be? It will be 1 by x under root x twice. How it is going to come? I'll show you. Because in the denominator it is under root x. When the under root x will go in the numerator, this root x will go in the numerator. It is going to be x to the power half. In the denominator goes x to the power minus half. So when we take the differentiation of x to the power minus half, what do you get? Minus half will come in front, and this is going to be x to the power minus half minus 1. Minus half minus 1 is minus 3 by 2. So minus half minus 3 by 2, x to the power minus 3 by 2. So minus half 1 by x to the power 3 by 2. You can write it as x into x to the power half, because 1 plus half is 3 by 2. So x to the power half is root x. So minus half, x is already there, and x to the power half is under root x. So I am just changing the sign. It is going to be 1 by 2x under root x. It was minus of that. So differentiation of x to the power minus half, I told you. Alright. So now this, what I am doing is, I am taking the LCM of this. Okay. So this is what I am talking about, the denominator, because 1 by that thing. And then the LCM of this is x plus 1 by under root x. So under root x will go up. X plus 1 will be in the denominator. 1 by 2 I am taking outside. Inside this only we have 1 by root x. So I will take the 1 by root x also common. Means root x from the denominator I can take common. When I can take common this root x, it will be only 1 minus 1 by x inside. That is the only thing remaining. So 1 minus 1 by x it will be. So what do you get here? Under root x we have already taken. So this is going to be x minus 1 by x when you take the LCM. So this is x minus 1 by x. Okay, what is the final? Half x minus 1 by x, root x gets cancelled, x plus 1 in the denominator. This is what you have to prove also. This is the final one, okay? Now y is equal to log of something. We have to prove dy by dx equals to sec 2x. Now there is certain things which we have to see, because there will be something I will be doing, and then I will be telling you, oh, this was a problem. Means we cannot go ahead with this. We cannot go ahead with this. We have to change the scenario. So log of anything will be 1 by that thing. That is 1 by under root 1 plus tan x by 1 minus tan x under root. So when it will be solved, under root 1 minus tan x will go in the numerator, and 1 plus tan x with the root goes in the denominator. Log of anything, differentiation will always be 1 by that thing. I hope you have a fair idea up till now here. Because log is just 1 by that thing. That is the reciprocal of whatever is inside log. But are we going to do like this? See, I am writing t as tan x. So 1 plus t, 1 minus t, root is what? Half. And we know that log a to the power b comes to the front. So half will come in front. So we will be getting rid of the root first of all. Okay. So we are using first the property of log so that we can bring this half in front. So it is going to be half log. We have not differentiated up till now. We are just solving, or we are just using the property of log. So half comes in from log 1 plus t by 1 minus t. Now log a by b. What is log a by b? Log a minus log b. Log a by b is log a minus log b. So half will be taken care later. So log 1 plus t, 1 minus t. T of course is tan theta, tan x. So log 1 plus t minus log 1 minus t. So we have applied another property of this, log a by b. Now we will differentiate. So we will differentiate now d by dx of log 1 plus t and d by dx of log 1 minus t. Okay. Log x is 1 by x, so it will be 1 by 1 plus t. And what is 1 plus tan theta? 1 plus tan theta differentiation is what? Tan theta is sec square theta. Alright. So it will be sec square theta. So let me write it as sec square theta minus, again log 1 minus t. So differentiation of this is 1 by 1 minus tan theta. And 1 minus tan theta, 1 will be 0, minus, and sec square theta, tan square theta is again sec square theta. So we have a minus, so it will become plus. So plus sec square theta. Now what we can do here is sec square we can take common. We have a half in the denominator. So we can take sec square x from the numerator and denominator 2. So what do you get inside? 1 by 1 plus t plus 1 by 1 plus t. Of course, t is tan theta here. Okay. So minus minus became plus. So we have 1 by 1 plus t plus 1 by 1 minus t. And sec square x by 2 we already taken common. So let us take the LCM. 1 plus 1 minus t goes here, 1 plus t goes here, 1 plus t into 1 minus t in the denominator. So 1 plus t into 1 minus t is 1 square minus t square. So 1 minus t square. Tan theta gets cancelled. You get 1 plus 1 as 2. It can be cancelled by this 2 in the denominator. So you get 1 by 1 minus t square. So 1 minus tan square theta. Please remember, sec square theta is what? Sec square theta is 1 plus tan square theta. It is not 1 minus tan square theta. I have written it wrongly. I'll just change it. Right? Now problem here is we have to get only sec 2x. So what do we do here? We will not use that. As I told you, 1 minus tan square theta is not sec square theta. It is 1 plus tan square theta. So sec square x, I am going to write it as 1 minus tan square theta. I just told you 1 plus tan square theta. Sorry. Sec square theta is 1 plus tan square theta. So 1 plus tan square theta. I have changed here. So sec square theta is 1 plus tan square theta. So in the numerator, sec square x can be written as 1 plus tan square x. Alright. And in the denominator, we have 1 minus tan square x. So 1 plus tan square theta by 1 minus tan square theta. This is what we got. Now, we know that the value of cos 2 theta is 1 minus tan square theta by 1 plus tan square theta. We already know that from our trigonometry. So, in order to solve this, can we just write it as 1 minus t square by 1 plus t square? Because cos 2 theta, let me just write it again. Cos 2 theta is 1 minus tan square theta divided by 1 plus tan square theta. You already know that. But we got 1 plus tan square theta by 1 minus tan square theta. So we need a reciprocal. So you can write it as 1 by 1 minus tan square theta by 1 plus tan square theta. This is cos 2 theta, the denominator. So 1 by cos 2 theta it will be. So cos 2 theta is sec 2 theta or sec 2x. Theta and x I am interchangeably using. It is sec 2x. So here I told you sec square equals to 1 minus tan square, which was wrong. Sec square theta is 1 plus tan square theta. Now this also has the same flavor as we have done already. So y is under root x plus 1 by under root x. We have to prove that 2x into dy by dx is equal to under root x minus 1 by under root x. Y is those who want to do by themselves, and how to write, that's why I always give the answer, right? But how to do this? Let us differentiate. Root x is 1 by twice of root x, and 1 by root x I just told you in the previous question, one of the previous question. It is minus 1 by 2x root x, right? So 1 by 2 root x we can take common, you get 1 minus 1 by x. So 1 minus 1 by x is x minus 1 by x. And then we have 1 by twice of under root x. Alright? So this is dy by dx. Now you need a 2x here. So you can take these 2 and this x here. So I am taking 2x dy by dx here. What is remaining? X minus 1 by under root x. So just separate it. X by under root x minus 1 by under root x. X by under root x is nothing but root x. How? X to the power 1, x to the power half in the denominator. Half goes up. It is going to be negative. 1 minus half is half. So x to the power half is root x. It is root x minus 1 by root x. 2x dy by dx is this. I hope you got the idea. You have to write like what is given on the. The next question is, so the normal version of this type of question we have already done. And how to prove that it has some expression coming out of it with a dy by dx inside it. That's what we have to see. So in order to have a reference how to write, I have given you the solution. But those who actually want to see how the question is being done, dy by dx, the numerator here, the numerator and denominator I am indicating, assuming it to be u and v, the quotient rule has to be applied. But since we in the numerator we have x sine inverse x, that transpires to be a product rule solution. Alright. So let us see. First the denominator will be the square of whatever is in the denominator. So under root 1 minus x square, it will be 1 minus x square only. So this is the denominator we have. Then under root 1 minus x square will be here. Under root 1 minus x square it will be. Please remember, this d by dx it will come here. On the right it will be x plus y by x. So we have to be very vigilant how we are solving it. We cannot cancel things out. We have to see what the solution wants. Now d by dx of s x sine inverse x, that will be performing with the product rule. Then x sine inverse x in the front, and d by dx of under root 1 minus x square. So anything with the root will be 1 by twice of under root of that thing. So we will just write it like this, 1 by twice of under root 1 minus x square. Okay. So 1 by twice of under root 1 minus x square. Then we will do the differentiation of 1 minus x square. That is going to be minus 2x. So 2 gets cancelled. Finally, the differentiation of under root 1 minus x square will be negative of x by under root 1 minus x square. So minus minus I took it as plus, and x by under root 1 minus x square I am writing. Alright. Now, x sine inverse x we have to differentiate it, and that will be done by the product rule. So let us see now. X sine inverse x, we will apply the product rule. So first x, then d by dx of sine inverse x, then we have the sine inverse x and d by dx of x. So x sine inverse x is 1 by under root 1 minus x square, and then we have plus sine inverse x, and d by dx of x will be 1. So I am not writing it, it will be just 1. Alright. So what we are going to write final here is under root 1 minus x square into x by under root 1 minus x square. Then we have plus sine inverse x, and then we have plus, so this x and x will become what? X square sine inverse x divided by under root 1 minus x square. I am doing the numerator only. Denominator I haven't written up till now. So now multiply this inside. Let us multiply this inside. And x under root x square will get cancelled. X plus sine inverse x into under root 1 minus x square plus x square sine inverse x divided by under root 1 minus x square. Up till here we have reached. So sine inverse x and sine inverse x are here. So let us take the LCM. Now please remember always a by b plus c by d. If we don't know how to find out the LCM, then how do? We multiply a with d, so ad plus b into c, and then in the denominator we have b into d. Okay. So let us multiply this. Under root will get cancelled. So x plus 1 minus x square sine inverse x will remain here. Now multiply these two. 1 into x square sine inverse x. So it will be x square sine inverse x. And in the denominator, we are going to get under root 1 minus x square. This is okay. And this is dy by dx. Now remember, denominator we already have 1 minus x square. The point we started. So this 1 minus x square I am talking about. And this whole was only the upstairs. And that means the upper part, numerator I was taking. Denominator, I haven't written 1 minus x square. So that will always be in the denominator. Dy by dx. So this we can take on the left hand side. Okay. So this all right on the right. What we can do? Because we have to find out the answer also. Now I am opening it. That means this, let me tell you again, 1 minus x square I haven't written anywhere. in the denominator, so it goes on the left. It was already there. And then we have this as sine inverse x minus x square sine inverse x plus x square sine inverse x. I am multiplying 1 minus x square with sine inverse x. So the x square sine inverse x gets cancelled. It will be x plus sine inverse x divided by under root 1 minus x square. That will be. Now this whole, if I write just like this, x I can take on the left hand side. So y by x is actually equal to sine inverse x divided by under root 1 minus x square. So in place of that, you can write y by x. So on the left, what we have? 1 minus x square divided by into 1 dy by dx is equal to x plus y by x, and that was the final result. Now y is equal to e to the power x minus e to the power minus x divided by e to the power x plus e to the power minus x. Dy by dx has to be proven to be 1 minus y square. So there are different methods, different trials can be done, because we have done already a question like that. You can write e to the power minus x as 1 by e to the power x. So you will get e to the power 2x minus 1 divided by e to the power x. And in the denominator, you can have e to the power 2x plus 1 divided by e to the power x. This gets cancelled. So e to the power 2x minus 1 divided by e to the power 2x plus 1. That is the final, and that will make the transition and the solution easier. Okay, so that's just the thing which will make it easier to solve. But in a normal way, in a way which we normally solve, the step by step thing, let us take this dy by dx we are going to take, and we'll just take it as numerator denominator, and we'll apply the quotient rule. So we have denominator square e to the power x plus e to the power minus x whole square. Then we have e to the power x plus e to the power minus x here, and d by dx of e to the power x minus e to the power minus x minus e to the power x minus e to the power minus x, and d by dx of what? E to the power x plus e to the power minus x. Now let us do the differentiation first. In the denominator, this is already there, and we will just reformulate it, and you will see that this becomes so easy after differentiation. So I am differentiating these two, which are the arrows are indicating. So e to the power x, e to the power minus x is e to the power minus x only, but differentiation of minus x will be minus 1. So a negative will come outside. Alright, there will be a negative coming out. So it will be e to the power x plus e to the power minus x. Here you have e to the power x, and e to the power minus x will be e to the power minus x. Again a negative will come outside. So this will be e to the power x minus e raised minus x. Now since these two terms are same, so it will be simply square e raised x plus e raised minus x whole square. Alright. So let me write it as ex plus e raised minus x whole square. This also e raised x minus e raised minus x whole square. So if you want to open it up, that is a plus b whole square formula, there will be cancellation of twice of e to the power x plus e to the power minus x. But that is not going to resolve our issue, because we have to see what we have to prove also. What we can do is we can separate these two terms with respect to the denominator. That is e raised x plus e raised minus x square divided by e raised x plus e raised minus x whole square, minus numerator we have e raised x minus e raised minus x whole square divided by e raised x plus e raised minus x whole square. Denominator remains the same. Now this gets cancelled. First term 1 minus, okay, this is what? Y. E raised x minus e raised minus x divided by e raised x plus e raised minus x is y only. So this one is y square only. This is y square. On the left side, what do you get? Initially we started with dy by dx only. So this dy by dx is equal to 1 minus y square. This is how you can match the answer also, but you have to write in a way I gave you the answer, the printed one. Now we have to prove that dy by dx is equal to log x minus 1 by x plus 1. So assume it to be 1 plus x, it is given. Just, normally the questions have some certain way we presented, like 1 plus x it is. It is not like, it is just x minus 1 by x plus 1. So this is the answer I am providing you. You have to write exactly like that. We have differentiate with respect to x, wherever you apply the chain rule or the product rule or the quotient rule, everything you have to write there. Because examiner knows everything. It is for you to know, and you have to tell examiner that I know this thing. So you have to write and present it. You have to show it in ink, written form. Okay, x minus 1 log x minus 1 minus x plus 1 log x plus 1 d by dx of this. This again d by dx, and then we will just subtract these two. So first term, second term, there are two terms with a subtraction sign. First term will apply the differentiation with respect to and with employing the product rule. So x minus 1 d by dx of log x minus 1. Then we have minus, plus it will be, plus log x minus 1 and d by dx of x minus 1. First I am doing this one only. So x minus 1, log of anything differentiation is 1 by that thing. So it will be 1 by x minus 1. And x minus 1 differentiation is what? X differentiation is 1. 1 differentiation is 0. So it will be 1 only. And this is going to be 1 only. I am not writing it. Now log x minus 1 d by dx of x minus 1, as we just saw what it will be 1 only. So x minus 1 gets cancelled, 1 plus log x minus 1 it will be. Now I am doing the differentiation of the second part, second term basically after negative. So let us change the color so that you understand I am doing the second part. X plus 1 and d by dx of, I am applying the product rule. D by dx of log x plus 1 and plus log x plus 1 now and d by dx of x plus 1 now. Okay. So dx plus 1 log is 1 by x plus 1. X plus 1 is 1 only. Here log x plus 1 and log d by dx of x plus 1 is 1 only. So this gets cancelled. You have a 1 here only. 1 plus log x plus 1. Now the first was 1 plus log x minus 1. This one. If this is A, this is B. The differentiation of A is this one. The differentiation of B is this one. Now we have to apply A minus B. So I am writing minus 1 minus log x plus 1. 1 gets cancelled. You will get log x minus 1 minus log x plus 1. So log x minus 1 minus log x plus 1. This is log A minus log B. So when we have log A minus log B, it will be log A by B. Log A minus log B is log A by B. So it will be log x minus 1 by x plus 1, and this is equal to dy by dx. Alright? And that is what we have to prove. Next one is y is equal to e raise x cos x, dy by dx is under root e raise x cos x plus pi by 4. Now how did this pi by 4 has come? For that we have to do certain multiplying and division in one of the steps. That is the whole idea of this question. So the basic idea is to differentiate. We have two terms, e raise x and cos x. So we'll apply the product rule. So e raise x d by dx of cos x plus cos x d by dx of e to the power x. E to the power x, cos x is minus sin x. So minus ex sin x, cos x here, e to the power x will be e to the power x. So I am taking e to the power x common and I am swapping the term so that I get a negative in between. It will be cos x minus sin x. e raised x cos x minus sin x. Now multiplying root 2 here and here. So I am introducing 1 by root 2 with cos x, 1 by root 2 with sin x. So when we introduce 1 by root 2, root 2 has to be multiplied also. So cos pi by 4 is what? Cos 45 degree. Cos 45 degree is what? It is 1 by root 2. So this 1 by root 2 has been introduced just because of that. So cos pi by 4 in place of 1 by root 2 you can write cos pi by 4. In place of 1 by root 2 you can write sin pi by 4, because sin pi by 4 is sin 45 degree and sin 45 degree is nothing but 1 by root 2. So cos pi by 4 cos x minus sin pi by 4 sin x, and in front you have root 2 into e to the power x. So this cos x, if you just consider it to be the first term, so cos x cos pi by 4 plus sin x sin pi by 4 is cos x plus pi by 4, cos a plus b. This is the formula of cos a plus b. So root 2 e to the power x cos x. So d by dx, dy by dx of this is root 2 e to the power x cos x plus pi by 4. If y is equal to half log of this term, we have to prove dy by dx is equal to twice of cosec 2x. So we have seen the trigonometric solution, differentiating it in different ways. So half is already there. The question might have been under root of this thing. This type of question can come. So just consider taking this half or any of the power inside the root term, log term with a root or whichever power. This power has to come in front. Now 1 minus cos 2x, with the trigonometric knowledge, we know that this is 2 sin square theta. 2 cos square theta is 1 plus cos 2 theta. So 1 minus cos theta is 2 sin square theta, 1 plus cos 2 theta is 2 cos square theta. So in place of 1 minus cos 2x, just write 2 sin square theta. In place of 1 plus cos 2 theta, you can write 2 cos square theta. Log is already there. Half is already there. So I am not differentiating it, I am just trying to simplify it. So you have log sin square theta by cos square theta, that is tan square theta. Now when we have a power with log, this power comes in front. So this 2 has to be taken in front. So 2 by 2 gets cancelled. You get log tan theta. So y equals log tan x. This is what you have to differentiate now. So the simplification have been done using all the knowledge we have with respect to the trigonometry. Log theta is, log x is 1 by that thing. So 1 by tan x is sec square x. Now sec square x and tan x we can write in terms of sin cos. Tan x is sin x by cos x. Cos goes up. And this sec square is 1 by cos square x. This cos gets cancelled. 1 by sin x cos x. Twice in the denominator, twice in the numerator. I have introduced it. 2 sin theta cos theta is sin 2 theta. 2 by, this is going to be sin 2x. So when it goes up, it will be cosec 2x. 2 was already there. Sin goes up, it will be twice of cosec 2x. And this is simply dy by dx. Alright. So this is what have to be proved, and we have proven it. If y is equal to x sin inverse x plus under root 1 minus x square, we have to prove that dy by dx is equal to sin inverse x. Now how you have to write, that is, we have differentiate, and wherever it is product rule or chain rule, whatever comes you have to write. And we have to give the resultant as sin inverse x. So when we perform dy by dx, the first one is x sin inverse x. So we will be performing product rule x sin inverse x. So first x, then d by dx of sin inverse x, followed by an addition, then sin inverse x, and d by dx of x, differentiation of x. Now this is x, sin inverse x is under root 1 minus x square. Then we have a plus sign, sin inverse x, and dy by dx of x is 1. Differentiation of x is 1. Okay, now the differentiation of the second part, which is under root 1 minus x square. So 1 by twice of under root 1 minus x square, whatever is under root, it will be 1 by twice of that thing. And then 1 minus x square, 1 is 0, x square will be 2x, so it will be negative 2x. So I am cancelling the 2, putting the negative. So what will be remaining? Only x. 2 gets cancelled, negative sign we have used, x by under root 1 minus x square. So what do you see here? The first term and the third term, this term and this term, they will get cancelled. Only sine inverse will remain. So this is how dy by dx is sine inverse x. So this is how you have to write, because we have used the product rule. So you have to write incomplete product rule like that. Y is equal to under root x square plus a square. We have to prove that y dy by dx minus x is equal to 0. So this is not a very heavy question. We can easily do, and you have already seen. So this is y equals under root x square plus a square, and this is dy by dx. Normally we will do what? Dy by dx and d by dx of that thing, x square plus a square under root. But the better way is, because we need y dy by dx, and that will only come, or that may come, when we square both the sides. So when we do the square, y square will be equal to x square plus a square, and the y square differentiation is 2y dy by dx, and this right hand side x square will be 2x, and this a square will be 0. It is a constant. So 2 gets cancelled, y dy by dx, x we take on the left hand side, so y dy by dx minus x is going to be equal to 0. Next is y is equal to e to the power x plus e to the power minus x. So dy by dx is under root y square minus 4. So there is a formula we are going to employ or use here, and that will be, see, y is equal to e to the power x plus e to the power minus x. Simple differentiation will do d by dx. E to the power x will remain e to the power x. E to the power minus x will remain as e to the power minus x, but will have a negative sign because minus x is also there. It will be negative here. Alright. Now, how to convert this in this form? Because we need under root. So we'll apply the formula, and we already know there is a formula, that is a minus b whole square, or a plus b whole square. A minus b whole square is what? 4ab. I'll show you how it will come. A square plus b square plus 2ab it will be, and minus a square plus b square minus 2ab. So a square plus b square plus 2ab minus a square minus b square plus 2ab. A square cancel, b square cancel, 2ab will be 4ab. So we have to write this e raise x minus e raise minus x. So when we need the a minus b, what we'll do? We'll take the 4ab with the a plus b whole square. So a minus b final will be a minus b will be under root a plus b whole square minus 4ab. The way I explained you. So this is a, this is b in our case. So let us write like this. A plus b whole square. So we have e to the power x plus e to the power minus x whole square, and minus 4 into a into b. What is a? E raise x. What is b? E raise minus x. The power gets added, x plus minus x, that is x minus x is 0. So e to the power 0, that is going to be 1. Alright. So this e raise x plus e raise minus x was what? Initially it was y. The question was saying y. So y square minus 4 under root. So this started all from dy by dx. So this is dy by dx, and that is what we have to prove. Alright. Y is equal to under root a squared minus x square. Prove that y dy by dx plus x is equal to 0. Now this you can try, because this is quite easy. But for the completion, I'll do it. Dy by dx. Now what we will do here is same thing what we have done in the previous one of the previous question. We are going to square it. Alright. So this is going to be a square minus x square. You can do that like that, but we'll square it. So when we square it, y square is equal to a square minus x square. So this is y square, so it will be y square will be 2y, and y is dy by dx, and a square will be 0, and this is going to be minus 2x. 2 gets cancelled. X on the left hand side bring y dy by dx plus x is equal to 0. This is your final answer. You have to write like this, okay? Squaring both sides, differentiating it with respect to x. This all thing you have to write. If x multiplied by y is equal to 4, prove that x into dy by dx plus y square equals 3y. So there are so many things which we will do here, okay? So you have to be very careful. So x, y equals 4. So what we'll do here is, one time we'll put x as 4 by y. One time we'll put y as 4 by x. Wherever it is required. We won't be using this xy equals to 4 anywhere. Mind it. This 4 by x dy by dx. So when you do the differentiation of 4 by x, you can assume it to be u, v, and you can do the differentiation in the question form. But 4 is a constant, so you don't have to worry about that. You just have to differentiate 1 by x. So x can be taken to the numerator. It will be x to the power minus 1. And differentiation of x to the power minus 1 is 4. Minus 1 will come in front. X to the power minus 1 minus 1. So finally you will get 4 negative 1 to the power x square. And that is, when you bring this x to the power minus 2 in the denominator, it is going to be minus 4 by x square. So dy by dx, still we are not getting the answer. So we have to do certain more thing. Now xy is equal to 4. And what did you write? Y equals 4 by x or x equal to 4 by y? X is 4 by y. Now you can put it here. Minus 4 in place of x square you can write. This is 4. 4 is 16. Y square goes up because it will be in the denominator. So it goes up in the numerator. 4 gets cancelled. There will be minus y square divided by 4. This is dy by dx. Still we are not getting the answer. So 4 will bring on the left hand side. It will be 4 dy by dx equals minus y square by 4. Still things are pending. So this minus, we need a 3. So how can we get 3 from 4 getting minus 1? So 3 minus 4 is minus 1. That we know already. So in place of minus y square, we can write 3 minus 4y square. In place of minus 1, we can write this. And we can also write 3y square minus 4y square. So 3y square minus 4y square, it is 4 into dy by dx. Alright. So this is 4y square I am taking on the left hand side. So what do we get finally is 4 dy by dx plus y square is equal to 3y square. Still we need some answer. So we divide both sides by x now. And what is xy equals 4? 4 by x is y. So in place of this you can write y. Dy by dx plus y square is equal to 3y square by 4, 3y square by x. Now you can change the position of x and y. In place of x, you can take it on the left hand side, y on the right hand side in the denominator. So x dy by dx plus y square is equal to 3y square by y gets cancelled. So 3y, x into dy by dx plus y square is equal to 3y. Final answer. This is the final answer. There are certain things which need to be explained here. Now, here there will be some effort. The only effort is algebra, nothing else, okay? The question is quite easy. Finally, you will see that under root a square minus x square will come. And how you have to write, I gave you in the answer already. So, we'll do the differentiation. There are two parts. X by 2 under root a square minus x square, assume it to be a square by 2 sin inverse x by a, assume it to be b, capital A, capital B. And then we'll differentiate the dA by dx, for example. So x by 2 is half, I am taking outside. So we have x under root a square minus x square. So x under d by dx of under root a square minus x square plus under root a square minus x square d by dx of x. I am not writing that because d by dx of x is 1. Half x by 2, half I have already taken outside. So half already taken outside, x d by dx of under root a square minus x square. So 1 by 2 twice of under root a square minus x square. And a square minus x square, of course we have already seen a square will be 0. It will be minus 2x basically. So minus 2x, let me write minus, 2 gets cancelled, x will be x square. So I have taken minus 2x, put in here and solved it in this step only. 2 I cancelled, x I combined with x, so it will be x square and negative sign. Plus under root a square minus x square. Now let us solve this first. Okay. So I told you how to take the LCM. So minus x square I am writing here. Root gets cancelled. So a square minus x square. And divide by under root a square minus x square. 2 is already there outside. So we will get a squared minus 2x square by under root a square minus x square. And half is already there. And so this is just this first part. Second part, we don't need to apply the product rule. Why? Because a square by 2 is entirely constant. So we don't have to worry about a square by 2. You can just keep it like that. So a square by 2, we'll talk about that later. But sine inverse anything will be 1 by under root 1 minus of that thing square. So 1 by under root 1 minus x square by a square. 1 minus x square by a square. Differentiation of x by a is simply 1 by a only, because d by dx of x is 1. 1 by a. Okay. So 1 by a will come outside. Okay. So 1 a square by 2 was already there. 1 by a gets cancelled. So you'll get a by 2. Only a by 2. Now let us concentrate on this. It is in the denominator. So it will be a square minus x square by a square under root. And under root a square in the denominator will go in the numerator. So it will be a only. Under root a square is a only. And since we have a by 2 outside, under root a square minus x square here. So finally we will get a square by twice of under root a square minus x square. This is the whole differentiation of the second part. Now let us combine it with a. We have to just add them. So this is a solution, this is b solution, which I regarded or indicated earlier. So we'll add them. So 1 by 2 is both have 1 by 2. So 1 by 2 I am taking outside, and I'll talk about this 1 by 2 later. I am subtracting now. Adding now. A square minus 2x square under root a square minus x square. I am writing this. And then we have to add it with a square by under root a square minus x square. So since the denominator are same, we can just combine the numerator. So it will be twice of a square minus 2x square. That is, denominator is same. A square minus x square. So a square plus a square is twice a square, and then we have minus 2x square. Now you can take 2 common. And you remember half was already there. I rounded it already. So just cancel this 2 with this 2. So a square minus x square by under root a square minus x square. So now multiply this under root a square minus x square, numerator denominator. Just multiply this. So numerator will give you a square minus x square into under root a square minus x square. Denominator and root gets cancelled. It will be a square minus x square. Now these two gets cancelled. Only under root a square minus x square will come. This is your final answer. This is your right hand side actually. So this is the final of this exercise. Thank you so much. Take care of yourself.